What's beyond the edge of space? Have you ever looked up at the night sky, far away from city lights, and felt really small, like a tiny speck on a tiny rock, floating in something too big to even imagine? You might start to wonder, what's out there really? And is there an end to it? Is there an edge of space? Here's the thing. When we talk about the edge of space, it's not like a wall you could bump into. It's not a place you could reach, stop, and look over. Instead, it's about what we can see and what we know. Our universe is so vast, and it's been around for such a long time, that light from the most distant things hasn't even reached us yet. Think of it like this. Light travels incredibly fast, but space is so enormous, even light from billions of years ago is still on its way. The part of the universe we can observe, the part whose light has actually reached Earth, is called the observable universe. Imagine you're standing in the middle of a huge, dark ocean at night. You can only see as far as the horizon, right? You know there's more ocean beyond that, but you can't see it from where you are. The observable universe is like our horizon in space. It's a huge bubble, but it's not everything that exists. We simply can't see past that horizon because the light hasn't had enough time to travel to us, or because space itself has stretched out too much since that light began its journey. And that's where it gets even trickier. The universe isn't just sitting still. It's actually expanding, getting bigger all the time. Think of a balloon being blown up. If you drew tiny dots on the surface of the balloon, as the balloon gets bigger, those dots move further and further apart from each other. They're not moving across the surface, but the surface itself is stretching. That's kind of what's happening with galaxies in our universe. They're all moving away from each other because the space between them is growing. This expansion means that even if light from a very distant galaxy started heading our way a long time ago, the space between us and that galaxy is stretching, making its journey even longer. It might even stretch so much that the light might never reach us. For thousands of years, people have looked at the stars and asked these same questions. Ancient Greeks, early astronomers, even your grandparents probably wondered about how big the universe is. And for all that time, the answer has always been bigger than we thought. Every time we build a more powerful telescope, we see more galaxies, more stars, more of this incredible cosmic tapestry. But the fundamental question of what's beyond remains. We might never actually know what's beyond our observable universe, because the information, the light, might never get to us. It's like trying to find the end of a line that keeps growing as you walk towards it. It's not a failure on our part. It's just how the universe works. And here's why that's okay, and even beautiful. The universe is full of mysteries, and this is one of its biggest. Not knowing everything isn't a bad thing. It keeps us curious. It keeps us wondering. It reminds us that there's always more to learn, more to explore, even if it's only with our minds and imaginations. The true edge might just be the limit of our understanding, always pushing outwards, always inviting us to dream bigger. And that sense of wonder, that feeling of being part of something so vast and mysterious, is a pretty amazing thing to carry with you. The mystery of dark matter. Imagine looking up at the night sky. You see countless stars, shining bright, and maybe even the soft glow of the Milky Way, our home galaxy. Everything seems clear, visible. But what if I told you that most of the universe, most of what holds galaxies together, is completely invisible? Not just invisible to our eyes, but to all our telescopes, all our scientific instruments. This hidden stuff is one of the universe's greatest secrets, and we call it dark matter. Here's the thing about dark matter. We can't see it, touch it, or even directly detect it. It doesn't reflect light, absorb light, or give off light. So, it's not like a dark cloud, because even clouds block light. This stuff just isn't interacting with light at all. So why do we even think it's there? Well, it's a bit like trying to figure out what's moving a swing in an empty playground. You see the swing moving, maybe spinning around, but no one is there pushing it. You know something has to be causing that motion. For a long time, scientists looked at how galaxies spin. They expected that the stars and gas at the edges of a galaxy would spin slower than the stuff closer to the center, just like planets farther from the sun orbit slower. But when they measured, they found something weird. The stars on the edges were moving just as fast, sometimes even faster, than the stars closer in. It was as if there was a huge amount of extra unseen mass pulling on them, keeping them moving that fast. It was like the galaxy had a lot more weight than we could account for by just looking at the stars and gas. Think about it this way. Imagine you're holding a bag of marbles. You know how many marbles are in there by counting them and weighing the bag. Now imagine the bag weighs a lot more than it should for the number of marbles you counted. You'd probably guess there's something else inside. Something heavy you can't see. That's kind of what scientists realized with galaxies. They could count the marbles, the stars, and visible matter. But the bag, the galaxy itself, weighed way, way more. The missing weight is what we call dark matter. It's called dark because it doesn't interact with light, and matter because it has gravity, which means it has mass and pulls on other things. In fact, scientists believe that dark matter makes up about 27% of the entire universe. All the stars, planets, and galaxies we can see, all the normal matter we are made of, only adds up to about 5%. The rest is dark energy, which is a whole other mystery. So, most of the universe is made of things we can't see and don't understand. It's a humbling thought, isn't it? To know that the universe we observe, with all its beauty and complexity, is just a tiny fraction of what's truly out there. It reminds us how much there is still left to discover, how many secrets the cosmos still holds. It tells us that even when things seem clear and understood, there might be a vast, invisible world just beyond our current reach, waiting to be revealed. And that's a pretty amazing idea to think about. Why time only goes forward. Have you ever stopped to think about time? Not just how fast it seems to fly by, but why it always moves in one direction. We remember what happened yesterday, but we can't go back and live it again. We can imagine tomorrow, but we can't jump forward to experience it right now. So, here's the thing. Why can't we rewind time like a video? Why does it only push us forward, always into the future? This is one of those deep questions that even the smartest scientists and thinkers have puzzled over for centuries. And the answer isn't just about clocks or calendars. It has to do with something fundamental about our universe, a rule that everything seems to follow. It's often called the arrow of time. Think about it this way. Things in the universe naturally tend to spread out and become less organized. Imagine your bedroom. If you don't tidy it, it doesn't magically get cleaner on its own, does it? Clothes end up on the floor, books pile up. You have to put effort in to make it neat again. The universe works similarly, but on a much bigger scale. This natural tendency for things to get messier, or less ordered, is a key idea. Let's use a simple example. If you drop a glass on the floor, it shatters into many pieces. You can never ever expect those pieces to jump back together, perfectly reforming the glass on their own. It just doesn't happen. The shattered glass is a more disordered state than the whole glass. Or think about an ice cube melting in a warm glass of water. The solid ice turns into liquid water. That water doesn't then just refreeze itself back into an ice cube in the warm room. It stays melted. That's because the tiny water molecules are more spread out and move more freely as liquid, which is a less organized state than being tightly packed in ice. This idea that things naturally move from order to disorder is the reason time seems to have a direction. Every moment that passes, the universe, in some small way, becomes a tiny bit more disordered. This isn't a bad thing. It's just how things are. This tendency is what gives time its one-way street feel. We can't unmelt the ice cube, unshatter the glass, or ungrow older. All these processes move in a direction that increases, or at least doesn't decrease, the messiness of the universe. So, time isn't just a line stretching out infinitely in both directions, where we happen to be moving forward. It's more like a river that always flows downstream. Our memories build up behind us, creating a past that is solid and unchangeable. Our lives are shaped by this flow. Every second is a new second, building on the one before it, carrying us into experiences that have never happened quite this way before. Understanding this doesn't make time any less mysterious, but it gives us a deeper appreciation for the moments we have. Time is not just a measurement, it's the very unfolding of reality, a constant movement forward into the new. And in that constant forward motion, there's a quiet beauty. A reminder that every moment is unique and can never be relived, making each one truly precious. The weird world of quantum physics. Have you ever stopped to think about what everything is made of? Not just the big stuff we see, like trees and houses, but the truly tiny things? The stuff so small we can't even imagine it? What if, down in that super small world, everything we think we know about how things work just isn't quite right? That's where quantum physics comes in. It's the part of science that tries to understand the smallest bits of everything. We're talking about atoms, and the even tinier pieces inside them, like electrons and photons. For a long time, people thought these tiny pieces would act just like little versions of bigger things. But here's the thing. They don't at all. Imagine you flip a coin. While it's spinning in the air, before it lands, is it heads or tails? You don't know, right? In our everyday world, we know it has to be either heads or tails, even if we can't see it yet. But in the quantum world, it's like the coin is both heads and tails at the very same time while it's spinning. It's in what scientists call a superposition, a mix of all its possible states. It only becomes one or the other when you actually look at it, when it lands. And this idea of looking is really important. In the tiny quantum world, just the act of observing something can change it. It's like the particles know you're watching. Before you look, a tiny particle might be in many places at once, or spinning in all sorts of directions. But the moment you try to measure it, or see it, it seems to pick one specific place or one specific spin. It's as if our attention forces it to decide. This isn't just about little mistakes in measuring. It's a deep part of how this world works. It truly seems to be a different kind of reality down there. Early in the 1900s, scientists started to discover these unbelievably strange rules. People like Albert Einstein and Niels Bohr, who were brilliant thinkers, found that the laws of physics they knew simply broke down at this tiny level. It was a huge shock. It meant that reality itself might be far stranger and more flexible than we ever dreamed. They argued about it for years because it just didn't make logical sense based on our everyday experiences. It's a bit like trying to understand the rules of a video game when you've only ever played board games. The rules are just totally different, right? In the quantum world, particles don't follow the smooth, predictable paths we see in our world. Instead, they seem to pop in and out of existence, or be in multiple places at once, until we interact with them. It truly makes us wonder what real even means when we talk about something so small. And that's why this part of physics remains one of the greatest mysteries. We can use the math to predict what these tiny particles will do, and that math works incredibly well. It helps us build things like lasers and computer chips. But understanding why it works that way, or truly picturing it in our minds, is almost impossible. It's a part of our universe that seems to resist being fully understood by the human mind. It reminds us that there are still vast, deep unknowns in the world around us, even in the very fabric of our being. And maybe that's okay. Sometimes, the most beautiful truths are the ones that continue to hold a little bit of mystery. What happens when we dream? Have you ever woken up from a dream, maybe one where you were flying or talking to a talking animal, and thought, what was that all about? It feels so real sometimes, doesn't it? But then you're awake, and it's gone, leaving only a strange feeling behind. Dreams are one of those truly mysterious things that our minds do, a secret show that plays every night when we close our eyes. Here's the thing. Even with all our amazing science, we still don't fully understand why or how we dream. We know what happens, mostly. When you sleep, your brain is super active, maybe even more active than when you're awake. It's not just resting, it's working hard, sorting through all the stuff you saw, heard, and felt during the day. Dreams are basically the stories our brains create during this time. They can be wild and crazy, or they can be simple reflections of your day. For thousands of years, long before scientists could study the brain, people tried to make sense of dreams. Ancient Egyptians, for example, believed dreams were messages from gods or spirits, clues about the future. They even had dream interpreters who would try to figure out what those messages meant. In some cultures, people believed that during a dream, your spirit actually left your body and went on an adventure. It was a big deal, a connection to something beyond our normal world. Today, we look at it a bit differently. Scientists think dreams might have many purposes. Imagine your brain as like a giant, messy locker. All day long, you're throwing in new books, papers, snacks, and clothes. When you sleep, your brain starts tidying up that locker. It decides what to keep, what to throw away, and where to file things so you can find them later. Dreams might be part of this sorting process. Your brain is trying to make sense of your memories, emotions, and thoughts. Sometimes, dreams might even help you learn or solve problems. Think about it like this. If you're trying to learn a new dance move or practicing for a big soccer game, your brain might actually replay those actions in your sleep. It's like a secret practice session. Or if you're worried about a presentation at school, you might dream about forgetting your lines. Your brain is trying to process that anxiety. Dreams can be a way for your mind to safely explore feelings or situations you're dealing with in real life. They can act like a pressure release valve for your emotions, letting you work through things that might be bothering you without even knowing it. But here's the mystery that still puzzles everyone. Why do some dreams feel so real? Why are some so vivid and clear, while others fade away the moment we open our eyes? Why do we so often forget most of our dreams, even the really wild ones? We don't have all the answers. The world of dreams is still mostly unexplored territory, a vast, swirling ocean inside our own heads. Maybe that's the beauty of it. Dreams remind us that there's a whole universe of thought and feeling happening inside us, even when we're not aware of it. They show us how incredibly complex and creative our own minds are, always working, always weaving stories. It's a quiet, personal wonder that happens every night, a secret window into the deeper parts of who we are. And in a way, that mystery makes them even more amazing. Are we truly alone in the universe? Look up at the night sky. What do you see? Billions of stars, right? Each one is like our Sunday, and many of them likely have planets circling around them. Some of these planets could even be similar to Earth. So, if there are so many planets out there, could some of them have life just like us? Or are we completely alone in this vast cosmic ocean? For a long time, people have wondered about this. It's a huge question that scientists and thinkers still debate today. We know our Milky Way galaxy is massive, holding hundreds of billions of stars, and our galaxy is just one of billions of galaxies in the universe. That's a mind-boggling number to think about. So, if even a tiny fraction of those planets could support life, the math suggests there should be life everywhere. Think about it. If you have a huge jar of marbles, and only 1 out of 1,000,000 marbles is blue, but the jar holds trillions of marbles, you'd still expect to find many blue ones. So, if life forms easily across the universe, why haven't we found any sign of it? Why is space so quiet? This question isn't new. Ancient people looked at the stars and imagined other worlds. Philosophers wondered if the universe was endless and if other beings lived out there. In more recent times, we've sent out probes, like the Voyager spacecraft, carrying messages from Earth just in case someone finds them. We've also built giant radio telescopes, like big ears, to listen for signals from other civilizations. We've been listening for decades, pointing these telescopes at different parts of the sky, hoping to pick up a message, a pattern, anything that shows someone else is out there thinking and living too. But so far, nothing. Just silence. Imagine you're walking on a giant beach, one that stretches further than you can see in every direction. There are more grains of sand on that beach than you can possibly count, maybe more grains than all the words ever spoken. Now, imagine one tiny grain of sand is our planet, Earth, with all its life. And somewhere out there, hidden among billions of other sand grains, might be another tiny grain just like ours, with its own unique forms of life. The problem is, how do you find that one specific grain of sand on a beach that never ends? It's incredibly difficult, almost impossible, with our current tools and understanding. The sheer size of the universe is a big part of why this question is so hard to answer. Light, which is the fastest thing we know, takes millions or even billions of years to travel across vast distances. So, even if there's a thriving civilization on a planet far away, their signals might not have reached us yet. Or, by the time they do, that civilization might be gone. Maybe life is rare, or maybe it's common but never lasts long. Perhaps advanced civilizations naturally destroy themselves, or they simply choose to stay hidden. We don't know. We truly don't. So, the question remains, are we alone? We don't have an answer, and maybe we never will. But here's the thing. Not knowing isn't always a bad thing. It keeps us curious. It makes us look harder, listen closer, and dream bigger. It reminds us of how special our own little blue planet is, filled with all kinds of amazing life. It makes us appreciate our home, right here, right now. Whether there's life out there or not, the mystery of the universe is a powerful reminder of how much there is still to explore and understand, both outside us and within ourselves. The puzzle of consciousness. Have you ever stopped and truly wondered what it feels like to be you? Not just what you look like or what you do, but what it's like to be the person experiencing this moment, right now. This feeling of being you, that's what we call consciousness. It's the part of you that knows you exist. It's the light that's on inside your head, letting you see, hear, feel, and think. Here's the thing. Everyone has it, but no one really understands it. It's your own private movie playing inside your mind, full of thoughts, memories, emotions, and sensations. It's why you can taste a sweet apple, feel the warmth of the sun, remember your first day of school, or wonder about the stars. It's your inner world, and it feels completely real to you. For thousands of years, brilliant thinkers, from ancient philosophers to modern scientists, have scratched their heads over consciousness. They've asked, where does it come from? Is it just what the brain does, like steam from a kettle? Or is it something more, something separate from the physical body? And how can something as physical as a brain create something as non-physical as a feeling or a thought? Imagine a super advanced robot. This robot can talk, walk, solve incredibly hard math problems, and even play a musical instrument. It can process information faster than any human. But does it know that it's doing these things? Does it feel proud when it solves a problem? Does it enjoy the music? Most people would say no. The robot might act like it's happy, but it doesn't feel happiness. That's the difference between something that acts intelligent and something that is truly conscious. We, as humans, don't just process information. We experience it. We feel joy, sadness, wonder, boredom. That's our consciousness at work. Think about a time you dreamed. While you were dreaming, everything felt real, right? You might have run, flown, or talked to people who weren't really there. But when you woke up, you knew it wasn't real. That feeling of waking up and knowing you're awake, knowing where you are, that's consciousness snapping into focus. But what is that snapping? Where does it come from? Scientists can map the brain. They can see which parts light up when you think or feel something, but they still can't find the exact spot where consciousness lives. They can't point to a neuron and say, there it is, that's the feeling of joy. It's like trying to find the movie inside a television set. You can see the wires and the circuits, but the story itself isn't a physical thing you can touch. So, this puzzle of consciousness remains one of humanity's deepest mysteries. It's personal and universal all at once. It's the very core of what makes you, you. And in that quiet awareness, in that simple fact of being, there's a profound wonder. It makes every sunrise a little brighter, every thought a little deeper, and every moment a quiet miracle we carry within ourselves, a secret universe unfolding inside our heads. Why do black holes exist? Have you ever looked up at the night sky and wondered what happens to the biggest, brightest stars when their lives finally end? It's a deep question, one that leads us to some of the most mysterious objects in the universe, black holes. They might seem like something out of a science fiction movie, but they are very real, and they are a natural, extreme part of how the universe works. So, what exactly is a black hole? Imagine a giant star, much bigger than our own Sunday, burning brightly for billions of years. Eventually, like all stars, it starts to run out of fuel. When a truly massive star dies, it doesn't just fade away. Instead, it can explode in a brilliant flash called a supernova. But here's the thing. If the star's core is heavy enough, after the explosion, The very center of it collapses in on itself with incredible force. It keeps crushing inward, getting smaller and smaller, until all that immense mass is squeezed into an unbelievably tiny space. Think of squeezing an entire mountain into a speck of dust. When that happens, the gravity around this super dense point becomes so unbelievably strong that nothing, not even light, can escape once it gets too close. That point of no return is called the event horizon. It's not a physical wall, but more like a boundary. Cross it, and you're pulled in forever. So, a black hole isn't really a hole in space, but rather a place where gravity is so strong it warps space and time around it, trapping everything that enters. For a long time, the idea of these dark stars was just a theory. Way back in the 1700s, a man named John Mitchell wondered about objects with such strong gravity that light couldn't escape. But it wasn't until Albert Einstein came along with his theories about how gravity works massive objects bend the fabric of space and time, that the true possibility of black holes really made sense. His math showed that these extreme gravity zones were definitely possible. For many decades, scientists weren't sure if they were just ideas or if they truly existed out there in space. But then, we started seeing evidence. How these invisible objects affect the stars orbiting them, or even feeling the tiny ripples in space-time when two black holes crash into each other. That told us they are real. You can think of it like this. Imagine a heavy bowling ball sitting on a stretched-out rubber sheet, like a trampoline. The bowling ball makes a deep dip in the sheet. If you roll a small marble near the edge of that dip, it won't just go straight. It will curve inwards, maybe even roll into the dip created by the bowling ball. That deep dip is like a black hole's gravity, bending the fabric of space. If the dip was deep enough, and the marble got too close, it would just keep rolling in, unable to climb back out. That's how a black hole captures everything, including light. So, why do black holes exist? They are a natural, awe-inspiring outcome of the lives and deaths of the most giant stars. They are not just cosmic destroyers, they are also powerful forces that shape galaxies, influencing how stars move and form. They are part of the universe's grand, intricate design, and they remind us that there are still mysteries out there so vast, so powerful, that our minds can barely begin to understand them. It's a humbling thought, knowing that such extreme, strange things are woven into the very fabric of reality. They stand as quiet, immense questions, waiting for us to keep exploring, to keep wondering about the incredible, sometimes impossible nature of the cosmos. The Big Bang. What was before it? Have you ever looked up at the night sky and felt really small, like a tiny speck in something unbelievably huge? And maybe, just maybe, you've wondered, how did all this? Everything? How begin? It's a question humans have asked for thousands of years, trying to figure out where we come from and how our universe started. For a long time, people just told stories or looked to ancient myths. But then, scientists started to piece together some clues. Here's the thing. Our best scientific idea for how the universe began is called the Big Bang. Now, when you hear Big Bang, you might picture a giant explosion in space. But that's not quite right. Think of it more like space itself, stretching and expanding very, very rapidly from an incredibly tiny, hot, dense point. Imagine blowing up a balloon. As the balloon gets bigger, points on its surface move further apart. That's a bit like how the universe expanded after the Big Bang. It wasn't an explosion in space. It was an expansion of space, creating all the space we see today, and all the time that goes with it. So, here's the really deep question. If the Big Bang was the very beginning of our universe, then what was before it? This is where it gets tricky, and frankly, nobody really knows. And that's okay. The problem is, our ideas of before and time and space are all tied to the universe as we know it. The Big Bang is believed to be the moment that time itself and space itself began. It's like asking what happens before the first page of a book is written, or what happens before a movie even starts playing. Before that first page, there isn't a story. Before that first frame, there isn't a movie. There's no before within the story itself. The Big Bang is considered that very first page, or that first frame, for our universe. So, asking what was before the Big Bang might be like asking what's north of the North Pole. The concept of north loses its meaning there. Scientists have many ideas, but they are just ideas right now. Some think our universe might be one of many, like bubbles in a giant cosmic foam. And maybe other universes exist or existed. Some wonder if time flows differently, or if our universe is part of an endless cycle of big bangs and big crunches, where everything collapses back in. But these are complex thoughts, and we don't have the tools yet to prove them true. And that's why it matters. This mystery reminds us of how much there is still to learn. It reminds us that even with all our amazing science and powerful telescopes, the universe still holds vast secrets. It encourages us to keep asking questions, to keep exploring, and to marvel at the sheer wonder of existence, even if we don't have all the answers. The unknown isn't something to fear. It's a vast playground for our curiosity. The secrets of deep ocean life. Have you ever stopped to think about what's really down there, deep beneath the ocean's surface? Not just a few feet, but miles and miles down, where the sun's light never reaches. It's a place of complete, eternal darkness, a place where the water is freezing cold, and the pressure is so immense it could crush a submarine like a soda can. And here's the thing, life thrives there. For most of human history, we thought such a place would be empty, cold, dark, and with crushing pressure. It seemed impossible for anything to survive. It was like believing life could only exist in a perfectly sunny, warm room, never imagining a creature that could live happily in a dark, ice-cold cave. We built our understanding of life around what we could see, what felt normal to us. But then, as we developed technology, we started sending robotic submersibles down into those extreme depths. And what we found completely changed everything we thought we knew. Imagine a world where fish glow in the dark, not just a little, but brightly enough to attract prey or find mates. Some have giant eyes to catch the faintest flicker of light, while others have no eyes at all, relying on other senses. There are creatures shaped like blobs, or living rocks, or impossible-looking jellies. Some don't eat other creatures or plants like we understand. Instead, they get their energy from chemicals bubbling up from cracks in the Earth's floor, a process called chemosynthesis. It's like a whole different way of life, built on rules we barely understand. Think about how you navigate a dark room. You might reach out, feel your way, maybe use your phone's flashlight. Now imagine trying to navigate a whole city, a whole world, where you can't see anything, and the air is thick, and there's an elephant sitting on your chest. That's a bit like what the deep ocean is for us. Our human senses, our bodies, our tools, they just aren't made for that environment. We can send down robots, sure, but those robots only show us tiny glimpses. It's like trying to understand an entire library by looking at just one page from one book. We get hints, but the full story remains hidden. So, here's what it means. The deep ocean isn't just a part of our planet we haven't fully explored. It's a vast, living mystery that pushes against the very edges of our understanding. It shows us that life is far more adaptable, far more creative, and far stranger than we ever imagined. It tells us that what seems impossible to us might just be a normal Tuesday for something else, and that's why it matters. It reminds us of our place in the universe, not as masters of all knowledge, but as curious students. It makes us pause and consider how much more there is to learn, right here on Earth, in plain sight but out of reach. The secrets of the deep ocean remind us that the greatest unknowns aren't always in distant galaxies. Sometimes, they are right below our feet, waiting in the silent, crushing darkness, gently reminding us how much we will probably never truly understand. How did life really start? Have you ever looked at a tiny blade of grass, or your pet cat, or even just your own hand, and really wondered, how did any of this begin? Not just how a baby grows, but how life itself, in the very first place, came to be. It's one of the biggest mysteries humanity has ever faced, a question that has puzzled thinkers for thousands of years. For a long time, people believed that life could just appear out of nowhere. They thought worms came from mud, or that flies just magically formed from rotting meat. This idea was called spontaneous generation. But then, smart scientists did experiments and showed that living things always come from other living things. So, a fly comes from a fly egg, not from old food. And that makes sense, right? But here's the problem. If every living thing comes from another living thing, then where did the very first living thing come from? It couldn't have come from another living thing, because there weren't any yet. This is where the mystery gets really deep. Scientists have a special word for the idea that life came from things that were not alive. Abiogenesis. It means life from non-life. Think about it like this. Imagine you have a giant pile of Lego bricks. They're just plastic pieces, right? They don't do anything on their own. But then, somehow, over an incredibly long time, those Legos somehow start to snap together on their own. Not just into a random blob, but into something that can move, repair itself, and even make copies of itself, creating more little Lego robots that are just like it. That's the huge leap we're talking about. From simple, non-living chemicals to the first tiny living cell. So, how could this have happened on early Earth? Scientists think that billions of years ago, our planet was a very different place. There was no oxygen in the air like we have today. Instead, there were gases like methane, ammonia, and water vapor, with lots of lightning and volcanic eruptions. It was a really harsh environment. But in this wild soup of chemicals, perhaps in warm ponds or deep-sea vents where hot water bubbles up from the earth, some simple chemical building blocks might have formed. Think of them as the very first, very basic Lego bricks. But it's not enough for building blocks to just exist. The real mystery is how these simple chemicals started to organize. How did they get a skin or a boundary, like a cell wall, to hold themselves together? How did they learn to copy themselves perfectly, making more of their kind? And how did they start to do useful jobs, like finding energy or building more complex parts? It's like the Legos not only building themselves into a robot, but also figuring out how to plug into an outlet and how to make more Legos. Scientists have lots of ideas and theories, but no one has been able to fully recreate it in a lab, and we don't have a time machine to go back and watch it happen. So, the question of how life truly began remains one of humanity's deepest unknown. We have pieces of the puzzle, and scientists are working hard every day to find more. But the exact moment, the precise way that non-living matter crossed the line into something truly alive and self-aware, remains a beautiful, humbling mystery. It reminds us that there are still grand, amazing secrets in the universe waiting to be understood, and some that might always be just beyond our grasp, inviting us simply to wonder. The mind's power. How placebos work. Have you ever felt better just because you thought something would make you better? Maybe you had a small cut, and your parent gave you a brightly colored bandage, telling you it was magic and would heal it super fast. And then, somehow, it felt less painful, even though it was just a regular bandage. That feeling, that strange power, is part of what we call the placebo effect. Here's the thing about placebos. They aren't real medicine. A placebo is often a sugar pill, or a harmless saline injection, or even a fake surgery. It has no active ingredients. It can't by itself actually fix a disease or heal a wound. But time and again, people who receive a placebo feel better. Sometimes, their symptoms even improve. This isn't just wishful thinking, though it connects to our thoughts in a very deep way. For a long time, doctors and scientists have seen this happen. They would give a patient something that looked like medicine but wasn't, and the patient would report feeling better. It was puzzling. How could something with no real power have any effect at all? It points to something incredible happening inside our own minds and bodies. Think about it like this. Your brain is an amazing, complex machine. It controls everything. Your breathing, your heartbeat, how you see the world, and even how you feel pain. When you believe something will help you, your brain can actually trigger your body to release its own natural healing chemicals. These are chemicals like endorphins, which are natural pain relievers, or dopamine, which makes you feel good. It's like your brain has its own built-in pharmacy. So, when you take a placebo, your brain says, "Okay, I'm getting medicine. Time to feel better." And then it starts doing things behind the scenes, using its own powers to try and make that happen. This isn't just in your head. It's a real, measurable physical response. Studies have shown that a placebo can sometimes even change brain activity, just as real medicine can. It's not just about pills either. Imagine an athlete who wears a specific pair of socks for every game. They believe these lucky socks help them play better. Maybe they do, not because the socks have magic powers, but because the athlete's belief makes them feel more confident, more relaxed, and more focused. That feeling of confidence can really improve their performance. It's the mind influencing the body in a powerful, subtle way. This doesn't mean you should ignore real medicine or doctors. Real medicine has proven chemicals that directly affect your body and fight illness. But the placebo effect reminds us that our mind is not just a passenger in our body, it's a powerful force, actively involved in our health and well-being. It's like our thoughts are whispering instructions to our cells, telling them how to behave, how to feel. The mystery of the placebo effect shows us how much we still don't fully grasp about ourselves. It shows that our beliefs, our expectations, and even the simple act of hoping can have a profound impact on our physical reality. It's a quiet reminder that within each of us lies a hidden strength, a capacity for healing and change that we are only just beginning to understand. It's like a secret language between our thoughts and our very being, a language of wellness we are slowly, curiously, learning to speak. Why do we feel déjà vu? Have you ever walked into a new place, or started talking to someone you just met, and suddenly a strange feeling washes over you? It's a feeling that says, I've done this before. I've seen this exact moment, even though I know I haven't. This peculiar experience, this flicker of recognition that feels both certain and impossible, is what we call déjà vu. The words come from French, meaning already seen, and it's one of those everyday mysteries that reminds us how truly complex our own minds are. For centuries, people have wondered about this feeling. Ancient thinkers wondered if it was a glimpse into a past life or a forgotten dream. Today, scientists and doctors have explored many ideas about why it happens. No one has one perfect answer, but most ideas point to how our brains sometimes work in quirky ways. One of the main ideas is that déjà vu is like a small, harmless glitch in our brain's memory system. Imagine your brain as a super-fast computer, constantly taking in information, storing memories, and making sense of the world. Sometimes, when a new experience happens, parts of your brain might process it a tiny bit slower than other parts. So, a new sight or sound might reach one part of your memory an instant before it reaches another. It's so quick, maybe just a split second, your brain tricks itself. It feels like you're experiencing something for the second time, because one part of your brain has just seen it, literally, a millisecond before the other part catches up. It's like when a video's sound starts a tiny bit before the picture, making it feel out of sync for just a moment. Another idea suggests that déjà vu happens when we encounter something new, but it strongly reminds us of something similar we've experienced before, even if we don't consciously remember that similarity. For example, maybe you're visiting a new city and walk into a cafe. The layout, the smell of coffee, the background music, separately, these are new, but together, they create a pattern that reminds your brain of a cafe from a different town you visited years ago, or even a scene from a movie you watched. Your brain tries to match this strong feeling to a memory. When it can't find an exact match, it creates that odd, already seen feeling. It's like when a new song sounds so much like one you know, and your brain gets confused for a moment. Sometimes, déjà vu can also be connected to how our senses work together. Maybe you briefly saw something out of the corner of your eye, a quick flash your brain noticed without fully understanding. Then, when you look directly at it, your brain gets the full picture. That first quick glance makes the second, complete look feel like a repeat. It's like thinking you heard your name, but it was just the wind, yet for a second, your brain thought it was real. Déjà vu is a very common experience. Most healthy people feel it at least once, especially during their teen years and early 20s. It's not a sign that something is wrong. It's a small, normal hiccup in the amazing dance of our mind. It reminds us that our brain isn't just a simple recording device. It's an active interpreter, constantly trying to make sense of the world around us. And sometimes, in its effort to organize, It creates these strange, fleeting moments of mystery. So, the next time that weird, familiar feeling washes over you, remember, it's not magic or a sign from another dimension. It's just your incredible brain, working hard, sometimes getting its wires crossed for a brief, puzzling instant. It's a gentle whisper from within, reminding us that even ordinary moments can hold a touch of the unexplained. It invites us to wonder about the hidden depths of our own understanding. It's a small, personal mystery that connects us all. It proves that even in our familiar everyday lives, there's always something new to feel and something deep to ponder. The unseen force we call gravity. Have you ever tossed a ball up into the air and watched it fall back down? Or maybe you've looked up at the moon in the night sky and wondered why it doesn't just float away into space. What is this invisible push or pull that keeps everything in place? From a simple apple falling from a tree to entire planets spinning around the sun. We call it gravity. Here's the thing about gravity. It's a force that pulls any two objects with mass toward each other. The more mass an object has, the stronger its pull. That's why Earth, being so huge, pulls us firmly to its surface. And it's why the Sun, which is even bigger than Earth, pulls on all the planets, keeping them in their orbits. We see it working every single day, everywhere we look. It holds our oceans in their basins. It makes rainfall. It keeps us from floating off into the vastness of space. Hundreds of years ago, a brilliant scientist named Isaac Newton watched an apple fall from a tree. This simple event sparked a huge idea in his mind. He realized that the same force making the apple fall was also holding the moon in orbit around the Earth and the planets in orbit around the sun. Newton figured out the rules for how gravity works. He wrote down equations that could predict how things would move because of gravity. And those rules are still used by scientists and engineers today to launch rockets into space or plan the paths of satellites. But here's what's really deep. Even Newton, with all his genius, didn't actually know what gravity was. He could describe how it behaved, but not why. He didn't know if it was tiny particles, or some kind of invisible wave, or something else entirely. And guess what? We still don't fully understand it even now. We use gravity constantly. We can measure its strength, and we can predict its effects with incredible accuracy. But the fundamental question remains, what is it? Think about it like this. If you push a toy car, you can see your hand making contact with the car. You understand how the force is transferred. But gravity is different. There's nothing visible connecting Earth to the moon or the sun to Earth. So how does the sun, which is millions of miles away, know to pull on our planet? How does its presence create a force across such a vast empty space? Some of the smartest minds on Earth are still trying to answer this question. They have ideas, like maybe gravity is linked to the fabric of space and time itself, bending and curving around massive objects, causing things to roll towards them, like marbles on a stretched trampoline. But these are just models, ways of trying to picture something we can't fully grasp. So, gravity is this silent, ever-present force that shapes our universe. It holds galaxies together, keeps stars burning steadily, and roots us to the ground we walk on. It's a core part of our existence, so familiar we rarely think about it. Yet, the true nature of this unseen pull remains one of the universe's biggest mysteries. It reminds us that even the most common things around us can hold secrets we may never fully unlock. And that's okay. Sometimes, the deepest understanding comes not from having all the answers, but from simply wondering. What is infinity, really? Have you ever tried to count to the very end? 1, 2, 3, and then what? Does it ever stop? What if you kept going forever? That feeling, that idea of something that just never, ever stops, that's what we call infinity. It's not just a really, really big number like 1,000,000 or 1,000,000,000 or even 1,000,000,000,000. It's bigger than any number you could ever imagine. It's the idea that there's always more, always another step, always another number after the one you just thought of. Our brains are built to understand things that have beginnings and ends. A story starts and finishes. A road begins and has a destination. But infinity doesn't play by those rules. It has no end. It's like a journey that you can always keep walking, without ever reaching a final stop. Think about the number line in math class. It stretches out in both directions, left and right, forever. You can always find a new number, no matter how far you go. People have thought about this idea for thousands of years. Even ancient thinkers, long ago, would scratch their heads trying to grasp it. They wondered about how many grains of sand were on a beach, or how many stars were in the sky. When you think about things that seem to have no limit, you're bumping right into the idea of infinity. Some thought it was impossible to truly understand because our minds are limited. How can we, with our short lives and small brains, understand something that goes on forever? But even if we can't fully get our arms around it, we can still think about it and wonder. Let's try an example you might know. Imagine you have a straight line on a piece of paper. It might look short, right? But if you think about all the tiny, tiny points on that line, how many are there? Between any 2 points, you can always find another point, and then another, and another. You could zoom in forever and never run out of new points. It's like magic. Even on a short line, there's an infinite number of points. Or think about time. We say, forever. But what does that really mean? It means time that never runs out, always ticking, without an end. It's a concept that stretches our minds, making us think beyond what we can see or touch. So, what is infinity, really? It's a powerful idea that reminds us how much is out there, beyond our everyday experience. It reminds us that some things are simply bigger than we can completely grasp. It's a concept that shows us the limits of our understanding, but also the endless wonder of the world and the universe. When we think about infinity, we feel a little small, but also a little amazed. It's a mystery that keeps us curious, pushing us to ask more questions, to look further, even when we know the answer might always be just out of reach. And that feeling of wonder, of never fully understanding, that's a deep part of being human. It's okay that some things are just too vast for us to fully know. Maybe that's part of their beauty. It leaves us with something to always think about, always explore in our minds. The deep mystery of sleep. What if I told you that a huge chunk of your life is spent doing something we barely understand? Every single night, you close your eyes, your body goes still, and you slip into a state called sleep. It feels so normal, something we just do. But here's the thing. Sleep is one of the deepest mysteries of human existence. We know we need it, but why we need it, and what exactly happens inside our minds during those hours, remains largely unknown. Think about it. For about 1/3 of your life, you are not truly awake, not truly aware in the way you are during the day. Your body rests, your muscles relax, your breathing slows. But inside your head, your brain is doing incredible, complex work. It's not just a simple switch off. Instead, your brain goes through different stages, like a series of quiet rooms it visits. There's light sleep, deep sleep, and then REM sleep, which stands for rapid eye movement, where most of your vivid dreams happen. Even though you're lying still, your eyes might be darting back and forth under your eyelids, like you're watching a movie in your head. For thousands of years, people have wondered about sleep. Ancient thinkers thought it was a journey to another world, a temporary death, or a time when the gods whispered to us through dreams. Some cultures believe that your soul actually left your body and traveled during sleep. Today, we have science, and we know a lot more about what happens physically. We can measure brain waves and see how they change from awake to deep sleep. We know that if you don't get enough sleep, you feel tired, grumpy, and can't think clearly. Your body doesn't heal as well. But even with all our knowledge, the core why is still a puzzle. Why can't we just rest while we're awake? Why do we have to shut down so completely? It's like your brain is a super busy computer that collects tons of information all day long. Thoughts, feelings, things you learn, things you see. When you sleep, it's almost like your brain is running a massive cleanup program. It sorts through all that data. It decides what memories to keep and strengthen, like important files you want to save. It gets rid of what isn't needed, like old emails. It repairs and recharges itself, getting ready for the next day's work. And what about dreams? Sometimes they're strange, sometimes they make sense, but often they're just wild and weird. They can feel so real. Some scientists think dreams are just your brain's way of making sense of all the information it processed during the day. Others believe they're a way for our brains to practice different situations, or even solve problems we're struggling with when awake. It's like a secret movie studio operating inside your head, creating stories you never asked for, but ones that might hold hidden meanings. We don't really know why we dream, or what the true purpose of those nightly stories is. Every night, as the world quiets down, we surrender to this mystery. We give up control, trusting that something essential is happening within us. We wake up feeling refreshed, often without remembering the journey we took through the darkness of sleep. This daily act, so simple yet so profound, reminds us that even in our own bodies, there are processes and purposes we are only just beginning to grasp. Sleep is a gentle echo of how much we still have to learn about ourselves and the universe we inhabit. Do animals truly talk to each other? Have you ever watched your dog bark at the mailman, or seen a bird sing from a treetop, and wondered what they were truly trying to say? We humans talk with words, forming sentences and sharing ideas. But what about animals? Do they have a language too? One we just can't understand? For a long time, many people believed that only humans had true language. We thought our ability to use complicated words and grammar set us apart from every other living thing. Animals, it was thought, just made noises or acted on instinct. But as we've learned more, we've started to see that animal communication is much deeper and more amazing than we ever imagined. When we talk about animals talking, we aren't usually talking about them using words like we do. Instead, we mean they share information. This can happen in many ways. It could be sounds, like a whale's song traveling through the ocean, or the chirps of crickets on a summer night. It could be through body language, like a dog wagging its tail to show happiness, or a cat arching its back when it's scared. Animals also communicate through smells, leaving behind scents that tell others about their territory or if they're ready to mate. Even touch can be a form of communication, like monkeys grooming each other to show care. Think about a common house cat. When it purrs, it's often showing comfort or contentment. When it hisses, it's warning you to stay away. These aren't just random noises. They carry clear messages. Or consider a dog. A low growl means danger. A happy bark might mean, play with me. A dog's ears, tail, and even the way it stands, all send messages to other dogs, and to us. They might not be using nouns and verbs, but they are definitely sharing information about their feelings, their needs, and the world around them. Scientists have spent years studying this. They found incredible examples in the wild. Take honeybees, for example. When a worker bee finds a great patch of flowers, it comes back to the hive and performs a special waggle dance. This dance isn't just random wiggling. It's like a map. The direction and length of the waggle tell the other bees exactly where the food is and how far away it is. It's a precise way of sharing vital information, all without words. Or consider dolphins. They use a wide range of clicks, whistles, and squeals. Scientists believe some of these sounds might be unique names for individual dolphins, helping them identify each other in the vast ocean. Here's the thing. We can observe these communications, and sometimes we can even respond to them in ways animals seem to understand. But truly understanding their language in the way we understand another human language, that remains a mystery. We can learn what a specific bark or purr usually means. We can guess what a complex bird song might be about, but we don't truly grasp the full depth of their thoughts, their feelings, or the intricate details they might be sharing with each other. We might see a mother animal comforting her young, and we understand the emotion, but we don't hear the specific message of reassurance she might be whispering in her own way. So, do animals truly talk to each other? Yes, in ways that are deeply important to them and their survival. They share information, express emotions, and build social bonds using their own unique forms of communication. But the way their minds work, the exact meaning behind every flutter of a wing or shift in scent, remains largely hidden from us. It reminds us that there is so much more to life on Earth than what our human senses can fully grasp. And perhaps that's okay. There's a quiet beauty in not knowing everything, in simply observing the profound connections animals share, and knowing that their world holds secrets we may never fully unlock. The human brain's hidden powers. Have you ever had a feeling about something? A strong sense of what might happen, even if you couldn't explain why? Or maybe you've worked on a tough problem, given up, and then later, the answer just pops into your head out of nowhere? These moments hint at something truly amazing and mysterious happening inside you, something we call the human brain's hidden powers. Our brains are always working, even when we don't realize it. We often think about our minds as just our conscious thoughts, the things we're actively focusing on, like reading this script or deciding what to eat for lunch. But that's only a tiny part of what's going on. Below the surface, a vast, powerful part of our brain is silently processing, connecting, and even creating. This is the realm of our unconscious mind, a place where information is stored, problems are quietly worked on, and insights can suddenly appear. For thousands of years, people have tried to understand these deeper parts of themselves. Ancient cultures sometimes called these feelings intuition or gut instincts. They believed these thoughts came from spirits or from a deeper connection to the world around them. Much later, in modern times, thinkers started exploring the idea of an unconscious mind. They realized that many of our decisions, feelings, and even some of our actions come from places we're not fully aware of. It's like a huge library inside your head, with countless books of memories, experiences, and information, and only a few are on the currently reading shelf. The rest are there, waiting, influencing you without you even knowing it. Think about riding a bicycle. When you first learn, you have to think about every single movement, pedaling, steering, balancing. It's a lot of conscious effort. But after a while, you don't think about it anymore. You just do it. Your brain has moved that skill from your conscious awareness into a deeper, automatic part of itself. It's no longer a series of steps you have to remember. It's just something your body and brain know how to do. This is your brain's hidden power at work, taking complex tasks and making them smooth, natural, almost magical. Here's another example. Imagine you're trying to remember the name of a movie, and you just can't get it. You try really hard, but nothing. Then, later, when you're doing something completely different, like walking home from school, the name suddenly just clicks. Your brain didn't stop working on it. Even though you weren't consciously thinking about it, a deeper part of your mind was searching, sorting through all the information it had, until it found the answer and presented it to your conscious mind. These hidden powers also show up in our dreams. Our dreams are often our brain's way of sorting through the day's events, processing emotions, and sometimes even solving problems or creating new ideas, all without our conscious mind directing it. It's a mysterious, complex process that we still don't fully understand. Why do we dream what we dream? What do certain symbols mean? Much of it remains a secret, locked away in the deeper parts of our own minds. So, when you feel a sudden flash of insight, or a strong hunch about something, remember that it's your brain's incredible, unseen abilities at work. These hidden powers remind us that there's so much more to our minds than what we consciously experience every day. They are a profound part of what makes us human, a constant source of wonder, and a reminder that even within ourselves, there are still vast, beautiful mysteries waiting to be explored. And maybe, just maybe, some of these mysteries will always remain just beyond our full grasp. What exactly is a thought? Have you ever really stopped to think about what a thought actually is? It seems so simple, right? We have thoughts all the time, but if someone asked you to point to one, or to describe exactly what it's made of, could you? It's one of those big mysteries woven into the very fabric of being human. In its simplest form, a thought is something that happens in your mind. It's an idea, a memory, a feeling, a question, or a plan. When you imagine what you want for dinner, that's a thought. When you remember a funny moment from last week, that's a thought. When you wonder why the sky is blue, that's a thought too. They float in and out of our awareness, like whispers or images, shaping our inner world. Your brain is where all this magic seems to happen. It's an amazing, complex organ made of billions of tiny cells that communicate with each other using electrical signals and chemical messages. When these signals fire in certain ways, somehow, they create what we call a thought. But here's the thing. We can see the brain activity, we can measure the electricity, but no one has ever truly seen or touched the thought itself. It's not a physical object. It's an experience. For thousands of years, smart people have wondered about this. The ancient Greeks, like a thinker named Plato, pondered where ideas came from. He even suggested that maybe our thoughts were like glimpses of perfect, unchanging ideas that existed in a different realm. Much later, a French thinker named René Descartes famously said, "I think, therefore I am." For him, the very act of thinking was proof that he existed. He believed that the ability to think meant there was a mind that was separate from the physical body, a place where these non-physical thoughts lived. Even with all our scientific progress today, the exact connection between those tiny brain signals and the rich, vivid experience of a thought is still a deep puzzle. Think of your mind like a vast, open sky. A thought is like a cloud forming there. It might be a small, wispy cloud, like the quick thought of, "I'm hungry." Or it could be a big, complex storm cloud, like when you're trying to figure out a really hard math problem, with lots of different ideas swirling together. These clouds appear. They change shape as you add more to the idea, and then they can drift away, making room for the next one. They aren't solid. They are ever-changing, born from the currents of your mind. Let's use an everyday example. Imagine you're trying to come up with an idea for a creative writing assignment. You might first think of a space adventure. That's a thought. Then you picture a talking dog. Another thought. Then you remember a book you read about a secret garden, and you wonder if you can combine these. Each of these mental images, memories, and ideas that pop into your head is a thought taking shape. You're not physically seeing a space adventure, but your mind is creating that experience. What we do know is that thoughts are incredibly powerful. They shape our feelings, our actions, and how we understand the world. They allow us to learn, to remember, to plan, and to dream. Without thoughts, we wouldn't be who we are. They are the silent architects of our inner lives, always there, always flowing. The mystery of what a thought truly is, where it comes from, and how it becomes such a personal, vivid experience, remains one of humanity's most profound and beautiful questions. It's a quiet wonder, always unfolding within us. The mystery of free will. Think about this for a moment. Do you truly choose what you do? Every day, you make many choices. You pick clothes, decide what to eat, or choose which game to play. It feels like you're in charge, right? Like your mind is the captain of your ship. But what if that feeling is just an illusion? What if your choices aren't truly yours? This is a very old, very deep question. Do we have free will? For thousands of years, people have wondered about this. Ancient thinkers and early scientists looked at the world. They saw things behaving in predictable ways. A ball rolls down a hill because gravity pulls it. Water boils when hot. Everything seems to follow rules. So, they started asking, are human beings different? Or are we also just following a very complicated set of rules? Here's the thing. Free will is the idea that we can make our own decisions. It means our choices are not simply the result of past events. Not just our genes, our upbringing, or our brain's wiring. It means when you choose an apple over a cookie, you truly could have chosen the cookie. It wasn't already decided for you. But here's the problem. Science shows our brains are incredibly complex. Billions of tiny parts, like neurons, work together. They communicate with electrical signals and chemicals. So, some people wonder if our thoughts and choices are just the outcome of these tiny reactions. If that's true, then maybe our choices are just a chain reaction, like dominoes falling. If you knew every signal in your brain and every past influence, could someone predict your next move? If so, where is the free part? Imagine reaching for pizza. You feel like you're deciding to pick it up, but perhaps the urge and the action were already set in motion by things in your brain and body you don't even know about. Maybe the pizza's smell, your hunger, and tiny brain signals all combined. They made that choice for you before you even realized it. You think, I want pizza, but maybe the want was already a done deal. This isn't about saying you're a robot. It's about how complex we are. Some scientists even show brain activity for a decision can happen a split second before a person is aware of making it. That's pretty wild to think about. It makes you wonder who's really in charge. So, here's what it means. If we truly have free will, we are fully responsible for our actions. Our successes are ours, and our mistakes are too. But if our choices are determined by things outside our control, then perhaps blame and praise don't make as much sense. This question changes how we think about right and wrong, justice, and what it means to be human. No one has a clear answer to the mystery of free will. It's one of those big, deep questions humanity keeps asking. It touches the very core of who we believe ourselves to be. It's a puzzle that makes us pause and reflect, making us curious about our minds and the true nature of reality. And perhaps the mystery itself is part of what makes us human. We get to think about it, even if we never fully understand it. Why we forget important things. Have you ever studied really hard for a test, felt like you knew everything, and then a few days later, some of that information just vanished? Or maybe you met someone new, learned their name, and moments later, it was gone from your mind. It's a strange feeling, isn't it? This idea of forgetting important things we thought we knew, makes us wonder about our own minds. Why does our brain do this? Why do we forget? Here's the thing. Forgetting isn't always a bug in our system. Sometimes, it's a feature. Our brains are amazing, but they are constantly bombarded with information. Imagine your brain as a giant library. Every day, thousands of new books arrive. If you kept every single piece of paper, every doodle, every conversation, every random thought, that library would become an unusable mess. You wouldn't be able to find the truly important books amidst the clutter. So, our brain has a kind of librarian, a filtering system. This system decides what's important enough to keep and what can be let go. One way we forget is simply by not using information. If you learn something new but never think about it again, the connections in your brain that hold that memory start to fade. It's like a path in a forest. If no one walks on it, it slowly gets overgrown and disappears. But if you walk the path often, it stays clear. This is why reviewing notes or practicing a skill helps us remember. We are, in a way, walking that path over and over. Then there's what we call interference. Sometimes, new memories push old ones out, or old memories make it harder to learn new ones. Think about learning a new dance move. If you already know a similar move, your brain might mix them up at first. The new information gets tangled with the old. Or, if you learn many different things in one day, they can start to blur together, making it harder to recall specific details from each one. For a long time, thinkers and philosophers have wondered about memory. Some saw forgetting as a curse, a flaw that kept us from perfect knowledge. But others, even ancient Greek thinkers, understood that our minds need to make space. They hinted that maybe it's not just about losing information, but about making room for new understanding. It's like how a computer needs to clear its cache or delete old files to run smoothly and take in new programs. Our brains work in a similar way. They can't hold on to absolutely everything from every second of our lives. Think about your phone or computer. If you take too many photos or download too many apps, eventually it runs out of space, right? It slows down, or it can't save new things. Your brain is a lot like that, but much more complex. It's constantly deciding what's important, what's useful for your future, and what can be safely archived or even deleted. This process often happens during sleep, when your brain sorts through the day's events, deciding what to keep and what to discard. This is one of the reasons a good night's sleep is so important for learning. So, forgetting isn't always a sign that something is wrong. Sometimes, it's a sign that your brain is working exactly as it should. It's clearing out what's no longer useful, making room for new ideas, new experiences, and new growth. It allows us to adapt, to move past old hurts, and to focus on what truly matters in the present moment. Forgetting, in this way, helps us build a future, not just carry the weight of every single past moment. It's a quiet, necessary part of being human. The deepest parts of our oceans. Have you ever looked at a globe and seen how much of our planet is covered by water? It's a vast blue mystery. And have you ever wondered what really lies at the very, very bottom of that water? Not just the ocean floor near the coast, but the deepest, darkest parts, where sunlight has never, ever touched. These aren't just deep. They are the most unknown and mysterious places on Earth, perhaps in our entire solar system. For hundreds of years, humans have sailed the oceans. We've explored new lands, climbed the highest mountains, and even sent robots to other planets. But the true bottom of our own planet, the deepest parts of the ocean, have remained mostly hidden. Think about how much we know about the surface of the Moon or Mars. We have detailed maps and pictures, but for the vast, dark world beneath the waves, we know much, much less. When we talk about the deepest ocean, we are talking about places like the Mariana Trench. This is a massive, curved canyon in the Pacific Ocean. It's the deepest known part of any ocean on Earth, and inside this trench is a place called the Challenger Deep. This point goes down almost 7 miles. To give you an idea of how deep that is, imagine taking Mount Everest, the world's tallest mountain, and putting it upside down into the Challenger Deep. The very top of Everest would still be more than a mile underwater. It is a vast, cold, dark canyon. Under pressure you can barely imagine. What kind of pressure? Well, if you've ever swum to the bottom of a deep pool, you might feel the water pushing on your ears. That's a tiny bit of pressure. At the Challenger Deep, the pressure is about 1,000 times stronger than the air pressure we feel at sea level. Imagine having the weight of almost 50 huge jumbo jets piled up on top of you, all on one small spot. That's the kind of crushing force we are talking about. Only a handful of very special, extremely strong submersibles, robot explorers, or small sturdy submarines have ever managed to withstand this amazing pressure and visit these extreme depths. Think about how much we explore in our daily lives. We explore new apps on our phones, new games, new streets in our town. We learn about so many things. But for the deepest parts of our oceans, less than 5% of them have been explored in any real detail. It's like having an enormous library, but we've only opened a few books and read just the first page. So many stories, so many strange creatures, and so many secrets are still waiting there, perhaps never to be truly discovered. This fact, that so much of our own world remains a mystery, tells us something important. It shows us the limits of what we can understand and explore. Even with all our amazing technology, we can build rockets that go to space and powerful computers that do incredible things. But Earth itself holds places that are just too challenging, too extreme, for us to truly grasp or fully explore. And here's the thing. Sometimes, it's okay for things to remain a mystery. Knowing that there are places we can't fully understand, places that are still unknown, can be a quiet and deep wonder. It reminds us that our world is far bigger and more mysterious than we sometimes realize. It shows us a kind of humility, a sense of awe for the vastness of nature. And it reminds us that some of the deepest truths, like the ocean's floor, might forever stay just beyond our full reach, a silent, dark testament to the powerful unknown that surrounds us, even on our own planet. What is energy made of? Imagine a world without movement, without heat, without light. What would that even be like? Pretty dark and still, right? Everything around us, from the smallest atom to the biggest star, is constantly doing something. It's moving, changing, glowing, and all of that doing needs something we call energy. But have you ever really stopped to wonder, what is energy anyway? Is it a thing you can hold, or see, or touch? Here's the thing. Energy isn't really a thing in the way a rock or a tree is. You can't put it in a box. It's more like an idea, a concept we use to describe the ability to do work or cause change. Think of it like this. If you push a toy car across the floor, you're using energy. If a light bulb glows, it's releasing energy. If the sun warms your face, that's energy at work. Energy is the power behind every action, every transformation, every single event in the universe. It's what makes things happen. For thousands of years, people have noticed this constant motion and change. Ancient thinkers often talked about a life force or a spark. They saw how fires burned, how plants grew, how animals moved, and they knew something unseen was making it all happen. They sensed its presence, but it remained a deep mystery. It was almost magical, this invisible engine of the world. Different cultures had different names for it. Prana, chi, spirit. They might not have used the word energy, but they were trying to grasp the same big idea. Something vital and active flows through everything. Centuries later, as science grew, people started to measure and describe energy. Scientists like Sir Isaac Newton observed how forces caused motion, and how that motion carried a kind of vigor. They saw energy could change forms. Like the chemical energy in your food becomes the kinetic energy you use to run, or the energy of falling water can be turned into electricity. And then a really important idea came along with Albert Einstein. He showed us that mass and energy are basically two sides of the same coin. His famous equation, E mx c² tells us that even a tiny bit of mass can hold a huge amount of energy. This means matter itself, everything you see and touch, is basically frozen energy, waiting for the right conditions to be released or transformed. Think about your own body for a moment. When you eat food, that food has stored chemical energy. Your body then works to change that chemical energy into other kinds of energy. It becomes kinetic energy when you run or jump, thermal energy that keeps your body warm, and even electrical energy that allows your brain and nerves to send messages. You can't see the energy inside the food or inside your muscles, but you can definitely see its effects. You feel stronger, you think clearer, you move. The energy isn't a part of your leg. It's what makes your leg move. It's the action, not the actor. Another simple way to think about it. Imagine a battery in your television remote. It's full of potential energy, just waiting. You press a button, and suddenly, that hidden potential energy becomes the electrical signals that tell your television what to do, or it becomes the light energy that turns the screen on. You don't see the energy itself, only what it does. It flows. It transforms. But here's a truly amazing fact. Energy never really disappears. It just changes its disguise. This is called the law of conservation of energy. It's always conserved. So, what is energy made of? The deepest answer might be that it's not made of anything at all. It's not built from smaller pieces, like a wall is made of bricks or a car is made of parts. Instead, energy seems to be a fundamental truth of the universe. It's the active principle, the very essence of existence and change. It's what allows everything to happen, to be, to become. It is the doing of the universe. We can measure it. We can observe its effects. We can even turn one form of it into another, like sunlight into electricity. But truly understanding its core nature, its stuff, remains one of the universe's great puzzles. It's like asking what time is made of, or what thought is made of. We experience them, we live by them, but their deepest reality stays just beyond our grasp. Maybe that's okay. Maybe the mystery itself is part of what makes the universe so amazing. To live is to experience this constant flow of energy, this amazing power all around and within us, even if we never fully understand its secret heart. The universe's hidden language. Have you ever wondered if the universe speaks? Not with words like ours, but with a deeper, secret language of its own. A language made of rules, forces, and patterns so grand and strange that our minds might never truly understand them. It's like trying to listen to a song played from a different dimension, or looking at a masterpiece painted with colors our eyes can't even see. We can feel its presence, see its effects, but the true meaning remains just out of reach. Here's the thing. For centuries, people have tried to figure out how the universe works. We've used telescopes to gaze at distant stars and microscopes to peek into the tiniest particles. We've discovered amazing things, like gravity pulling everything down, or how tiny atoms build everything around us. This is like learning a few words or phrases of the universe's language. We know, for example, that math seems to be a part of it. Numbers and equations help us describe how planets move or how rockets fly. It feels like the universe is built on a framework of logic, a kind of hidden grammar. But then, there are parts of this language that just don't make sense to our everyday brains. Imagine trying to read a very old book from a culture long gone. You might see the letters, but the way the sentences are put together, the ideas behind them, are completely foreign. That's a bit like how we encounter certain parts of the universe. Take something called dark matter and dark energy. We know they're out there, Scientists can see how they pull on galaxies or push the universe apart. They are like invisible forces, shaping everything we see. But we can't touch them, can't measure them directly, and we don't know what they're made of or why they exist. They are like silent, powerful words in the universe's secret book, words that describe so much of what happens, but which we cannot truly read or understand. Think about it like this. You might play a video game and see amazing characters and worlds. You can see what they do, how they move, but you don't know the computer code that makes it all happen. You don't understand the complex programming language behind the scenes. Dark matter and dark energy are a bit like that. We see the effects, the incredible game of the cosmos playing out, but the fundamental code, the true language behind it, is hidden from us. We're observing the story without understanding the author's deepest thoughts. Sometimes, the universe seems to operate on ideas that challenge everything we thought we knew about reality. Things can be in two places at once, or connected across vast distances instantly. It's like the universe is saying something so mind-blowing that our human brains, built for daily life on Earth, struggle to even grasp the concept. It reminds us that our way of seeing the world isn't the only way, and perhaps not even the most complete way, and that's why it matters. This idea of a universe with a hidden language isn't scary. It's beautiful. It means there are wonders beyond our current understanding, mysteries that continue to call to us. It invites us to be humble about what we know and endlessly curious about what we don't. It reminds us that the universe is far bigger and stranger than we can imagine, and that's exactly what makes it so incredibly special to be a part of. The quiet, persistent mystery of it all is a language in itself, speaking to our sense of wonder, the weirdness of pure randomness. Have you ever thought about what it means for something to be truly random? Like really, truly random? Not just, I picked a card at random, or the weather is random today. We often use that word without thinking too much about its true, deep meaning. But here's the thing. Pure randomness is one of the most mysterious ideas in the universe, and it's something humanity might never truly understand. So, what is pure randomness? Imagine something happening with no cause at all, no pattern leading up to it, nothing you could ever predict, no matter how much you knew about everything else. It's an event completely cut off from everything that came before it. Most things we call random in our daily lives aren't actually pure randomness. When you flip a coin, it feels random, right? Heads or tails, 50-50ths. But if you knew exactly how much force you used, how the coin spun, the air currents, the exact angle it hit your hand, you could actually predict the outcome. It's just too complicated for our brains to calculate, so we call it random. But it's not truly random in a deep sense. It still has causes. True, pure randomness is different. It's when there are no hidden causes. There's nothing to calculate, no pattern to find. It just is. And that idea has puzzled people for thousands of years. Ancient thinkers often believed everything had a purpose or was controlled by gods or fate. The idea of something happening with absolutely no reason was hard to accept. It felt chaotic, unsettling. Even today, our brains are wired to look for patterns, for causes and effects. We want to understand why things happen. Pure randomness breaks that need. Think about the music app on your phone. It has a shuffle play option, right? It's supposed to play songs in a random order. But have you ever noticed how sometimes it plays songs by the same artist back to back? Or seems to repeat certain songs more often? It feels like it's not truly random. And you'd be right. Most computer programs that generate random numbers aren't actually creating pure randomness. They use complex math formulas. If you know the starting number, you can predict the entire sequence. It's like a super long, complicated list that just looks random, but it's not truly unpredictable. It's what we call pseudo-random, fake random. So, if even our best computers can't create pure randomness, where does it exist? Scientists think true randomness shows up at the smallest possible scales, in the world of atoms and tiny particles. This is the realm of quantum mechanics, a part of physics that studies things so small we can barely imagine them. In this incredibly tiny world, particles can appear in places without a clear reason. or their properties can change in ways that seem truly unpredictable. It's not because we don't have enough information. It's because the universe at that level truly seems to behave randomly. A tiny bit of radioactive material, for example, will decay, releasing energy. But no one can predict exactly when a specific atom will decay. It seems to happen purely by chance. This is where the weirdness comes in. If things can happen with no cause, no pattern, no reason, what does that mean for how we understand the world? It challenges our deepest beliefs about cause and effect. It means that some parts of the universe just are, without a story or a reason we can grasp. It means there are edges to our understanding, places where the universe simply doesn't follow the tidy rules we expect. And maybe, in that deep, unexplainable randomness, there's a kind of quiet wonder, a reminder that some mysteries are meant to remain forever beyond our reach. Why do we have emotions? Have you ever stopped to truly think about that sudden rush of excitement or the quiet ache of sadness that washes over you? We feel so many things: joy, anger, fear, surprise, disgust, sadness. But why? Why are these powerful, often confusing, sensations a part of us? It's one of humanity's deepest puzzles, a mystery woven into the very fabric of who we are. For a very long time, people saw emotions as something separate from logical thought, almost like a wild, untamed part of ourselves. Ancient thinkers wondered if feelings lived in the heart, distinct from the brain. They saw emotions as powerful forces, sometimes helpful, sometimes destructive, that humans had to learn to manage. It was like trying to control a strong current within a river. But here's the thing. Emotions aren't just random feelings that come and go. They are like a complex, invisible language our inner self uses to communicate with us and the world. Think of your emotions as a car's dashboard lights. When the check engine light comes on, it's not trying to make you upset. It's giving you important information. Something needs attention. In the same way, fear isn't just a bad feeling. It's a danger ahead signal telling you to be careful or to get away. Joy is like a all systems are working great light, encouraging you to keep doing what makes you feel good. Emotions play a huge role in our survival. Imagine our earliest ancestors. If they didn't feel fear, they wouldn't run from a predator. If they didn't feel disgust, they might eat something poisonous. These strong feelings push them to act quickly, to stay safe, and to pass on their genes. So, in a basic way, emotions are deeply tied to keeping us alive. But emotions are about more than just survival. They are also about connection and learning. When you feel joy with friends, it strengthens your bond with them, making you want to spend more time together. When you feel empathy, a kind of shared sadness, for someone who is hurting, it moves you to offer help. These feelings knit us together, creating families, communities, and societies. They help us understand each other without needing to say a word. A simple look, a sigh, a smile, these all communicate volumes. Emotions also teach us. When you make a mistake, you might feel a pang of regret or frustration. That feeling helps you learn not to repeat the same error. When you achieve something, the feeling of pride or happiness encourages you to keep striving. They are powerful feedback loops, guiding us through life's complex maze. Despite how essential they are, we still don't fully understand emotions. How does a chemical reaction in the brain become the vast, aching emptiness of sadness, or the soaring feeling of love? Why do some experiences trigger such strong emotions in one person, but not another? This profound mystery remains. We can study the brain, track neural pathways, and map out chemicals, but the experience of emotion, the deep personal feeling of it, remains largely unexplainable by science alone. It's like trying to describe the color red to someone who has never seen it. Perhaps that's okay. Maybe some of the deepest parts of being human are meant to be felt, to be experienced, rather than fully dissected and understood. Our emotions link us to the vast, complex, beautiful, and sometimes difficult world around us. They are a mysterious language we are always learning to speak, a silent acknowledgement that there is more to us than just logic and reason. They are the deep currents beneath the surface, reminding us how truly alive we are. The mystery of ancient stone structures. Have you ever looked at something incredibly old and massive, like a towering pyramid or a circle of giant stones, and just stopped to wonder, how in the world did they build that? It's a question that echoes through time, a mystery held within the very rocks themselves. For thousands of years, people across the world, from ancient Egypt to remote islands, managed to create astonishing structures out of stone. These weren't small projects. We're talking about huge pieces of rock, sometimes weighing many tons, moved over long distances and then carefully put into place. And they did all of this without the cranes, trucks, or power tools we have today. Think about that for a moment. This is the deep mystery of ancient stone structures. They stand as silent giants, like Stonehenge in England, with its massive stones arranged in a perfect circle, or the pyramids of Giza in Egypt, reaching for the sky with incredible precision. Then there are the huge stone heads on Easter Island, staring out to sea, each one carved and moved by people, using only basic tools and their own strength. We look at these things, and our minds struggle to grasp the scale of the effort. How did they cut such perfect shapes? How did they lift such heavy weights to such heights? And why? Here's the thing. We have some ideas, some theories about how they might have done it. Maybe they used ramps, or rolling logs, or even simple sleds. But the exact methods, the full steps, are lost to time. It's like trying to build a complicated Lego castle with no instructions and only having a few friends to help, and no picture of what it's supposed to look like in the end. You could probably figure out some parts, but the whole thing, done perfectly, without any modern help? That's what makes it so mind-boggling. They didn't just build things. They often built them with amazing accuracy, lining up with the sun on certain days, or with specific stars in the night sky. This tells us they had incredible knowledge, not just of building, but of astronomy and seasons. And that's why it matters. These structures tell us something profound about the human spirit, even if we don't fully understand how they built them. They show us that ancient people were incredibly smart, incredibly determined, and able to work together on projects that would take generations to complete. They had patience we can barely imagine. They had a deep connection to their world, to the sky, and to each other. Maybe they built these places for worship, or to honor their leaders, or to mark important events in the stars. We can guess, but we don't truly know their full reasons or the specific knowledge they held. The mystery of these ancient stones is a quiet reminder. It tells us that history holds secrets we haven't uncovered yet, and maybe never will. It shows us the vastness of human ingenuity, long before our modern age. It can be a little humbling to think about how much cleverness existed in the past, and how much we still don't understand about it. But it's also inspiring. It makes you think about what we could build, what mysteries we could solve. If we only had the same kind of focus and determination, and if we were willing to look beyond what we think we already know, these silent, stony questions simply invite us to keep wondering, keep learning, and keep searching for answers that might always remain just out of reach. What is pure nothingness? Have you ever tried to imagine a truly empty space? Not just an empty room, but a place where absolutely nothing exists. No walls, no air, no light, no sound. Most of us might think of outer space, those vast, dark stretches between stars. But even outer space isn't truly empty. It has tiny bits of dust, faint light, invisible energy fields, and even gravity. So, if that's not pure nothingness, then what is it? Pure nothingness isn't just a lack of something. It's the absence of everything. Imagine a room completely empty. Now imagine there's no room, no walls, no floor, no ceiling, no air, no light, but also no darkness, no sound, but also no silence, no hot, no cold. It's not just empty space. It's the absence of space itself. And here's the really tricky part. No time. If there's no time, then nothing can start, and nothing can end. There's not even a before or after, because time itself isn't there. It's a concept so strange that our brains, which are always working with things that are, find it almost impossible to fully grasp. Our minds are built to see patterns, to categorize, to understand relationships between things. But how do you understand the absence of all relationships? all patterns, all things. For thousands of years, people have wrestled with this idea. Ancient Greek thinkers, like Parmenides, thought that nothingness couldn't truly exist. If it did, he argued, it would have to be something. He believed that if something is, it is, and if it is not, then it simply isn't. So, if nothingness is, then it's no longer nothingness, right? This mind-bending puzzle has troubled thinkers for centuries. And later, other philosophers wondered, if pure nothingness really existed, a state of absolute zero existence, how could anything ever come from it? It seems impossible for something to just pop out of absolutely nothing. Everything we see around us seems to have a cause, a beginning from something else. Here's a thought exercise you might try. Try to completely clear your mind. Think of nothing at all. Not a single thought, not a single feeling, not even a sound in your head, just nothing. It's incredibly hard, isn't it? Even when you try, you're still there, trying. You're still thinking about trying to think of nothing. Your brain is active. You exist. Your thoughts exist. It shows us that even our own minds, which can create incredible things, struggle to truly imagine a state where nothing is happening, where nothing exists, not even the mind itself. Imagine you have a piece of paper. You can draw on it, then erase what you drew. The paper is still there, just blank. What if you crumple the paper up? It's still there, just changed. What if you burn it? Now it's ash. Even ash is something. To get to pure nothingness, you'd have to get rid of the paper, the ash, the idea of the paper, the space it was in, the time it existed. It's like trying to remove the very stage on which everything plays out, but then removing the idea of a stage too. Thinking about pure nothingness can feel a little dizzying. Our universe is full of things. Our lives are full of things. People, ideas, feelings, objects. We are surrounded by existence, and we understand it in many ways. But pure nothingness? It's a concept that remains stubbornly out of reach for us. It challenges the very way our minds are built, because our minds are made to understand and create something. This mystery, the deep question of what might be beyond everything, reminds us of the vastness of what we don't know. It makes us appreciate the incredible wonder of the fact that anything exists at all, instead of simply nothing. Maybe that's okay. Maybe some mysteries are meant to remain just that, deep, quiet puzzles that remind us how much we still have to wonder about in this amazing, complex world we live in. The connection between mind and body. Have you ever stopped to think about how your feelings can actually change what happens in your body? Like when you're really nervous about a test, maybe your stomach starts to churn, or your hands get sweaty. Or when you're super happy and excited, you suddenly have lots of energy, even if you were tired a moment before. This isn't just a coincidence. It's a quiet, everyday mystery known as the connection between your mind and your body. For a long time, many smart people, thinkers, and philosophers wondered about this. They questioned if our minds, the part of us that thinks, feels, and dreams, were completely separate from our bodies, the physical form we live in. Imagine it like two different machines working side by side but never truly touching. Some believed this was true, that the mind was like a ghost in the machine, something apart from the bones and muscles and blood. But as we learned more about ourselves, especially how the brain works, a different idea started to grow. Today, we understand that your mind and body aren't separate at all. They are deeply, powerfully connected, always talking to each other. Your brain is part of your body, of course, but your thoughts and emotions which come from your brain also send signals throughout your entire system. Think of it like a giant, invisible network of messages. When you feel stressed, your mind sends signals that can make your heart beat faster, make your muscles tense up, or even affect how well your immune system fights off sickness. This is your body reacting to the signals from your mind. Let's use an example. Imagine you're walking home alone at night and you hear a strange noise behind you. Suddenly, your heart pounds, your breath gets shallow, and you might even feel a rush of energy, ready to run. This is your mind, interpreting the noise as a danger, sending an urgent message to your body. Your body then kicks into fight or flight mode, preparing you to either face the danger or run away from it. This happens automatically, showing just how linked your thoughts and your physical reactions are. It works the other way too. If you haven't slept well, your body feels tired and slow. This physical tiredness can make your mind feel foggy, irritable, or sad. Or if you eat healthy food and exercise, your body feels stronger, and this can lift your spirits and make your mind feel clearer and more positive. It's a constant conversation, back and forth, between your thoughts and your physical well-being. This connection is so profound that understanding it can help us live better. It reminds us that caring for our minds, being mindful of our thoughts, managing our stress, trying to find joy, is just as important as caring for our bodies through good food and exercise. And caring for our bodies helps our minds too. It's a loop, a cycle. The more we learn about this incredible bond, the more we see that to truly understand ourselves, we must see our mind and body not as two separate pieces, but as one amazing, interconnected whole, forever influencing each other in ways we are still just beginning to truly grasp. How did human language begin? Have you ever stopped to really think about the words you're hearing right now, or the ones you use every day? Imagine a world without them. No stories, no songs, no way to share your deepest thoughts or even just ask for a glass of water. It's almost impossible, isn't it? Language is such a core part of being human that we rarely stop to wonder where it came from. But that's the thing. We don't really know. The true beginning of human language is one of humanity's biggest, most beautiful mysteries. It's not just talking. Language is our entire system of communication. It's the sounds we make, the signs we use, and the rules we follow to put them together so others can understand. Think about how a baby starts. They make simple sounds, then single words, then two words, and suddenly they're building whole sentences. It feels like a natural path. But how did the very first humans start this journey from no words to a complex system of talking? For a long time, people thought language might have come from simply imitating sounds they heard around them, like the buzz of a bee or the crash of thunder. This is called the bow-wow theory. Or maybe it was just natural cries of emotion like ouch for pain or yay for joy. That's the poo-poo theory. But these ideas don't explain how we got to talk about ideas, feelings, or things that aren't even here right now, like yesterday's lunch or tomorrow's plans. Another idea is that language grew out of the need for early humans to work together. Imagine a group of people hunting a large animal or building a shelter. They needed a quick way to warn each other of danger, coordinate their movements, or share information about where the best berries were. Simple grunts or gestures wouldn't be enough for complex tasks. So, some thinkers believe that shared work pushed our ancestors to develop more detailed ways to communicate. And here's another thought. Maybe language started with gestures first. Before we could make complex sounds, perhaps our hands did the talking. We pointed, we mimed actions, we waved to say hello. Over time, these hand signals might have become more detailed. And then, slowly, the sounds we made with our mouths began to attach to those meanings, eventually replacing or complementing the gestures. You see this today when you use your hands to explain something, even while you're talking. The truth is, we don't have a time machine. We can't go back and watch the very first conversation unfold. There are no ancient recordings of early humans chatting. We can only look at clues, how our brains work, how children learn language, how other animals communicate, and what we know about early human societies. Every theory is like a puzzle piece, but we're missing the picture on the box. Think about it like this. Your brain is an amazing, complicated machine. It's designed to make connections, to understand patterns. When you learn to ride a bike, you don't just know how to do it instantly. You try, you fall, you adjust, and your brain slowly figures out the balance and movement. Language might have been similar. Our brains, over thousands of years, slowly figured out how to link sounds to meanings, then meanings to other meanings, building up a vast web of communication. So, while we may never fully understand the exact moment or way human language began, the mystery itself is a profound reminder. It shows us how unique and special our ability to communicate truly is. Every word you speak, every book you read, every story you share is part of this incredible, ancient journey. It's a journey that links us, not just to each other in this moment, but to all the humans who ever lived, connecting us across the vast stretch of time, one whispered word, one shared idea at a time. The mystery of our instincts. Have you ever felt a sudden urge, a strong feeling deep inside that makes you do something without even thinking about it? Like a quick jump back from something hot, or a sudden fear when you hear a loud crash? What if some of our most basic actions, the ones we just do, come from a place we can't fully see or understand? Here's the thing about instincts. They are like built-in programs, deep urges that are part of us from the moment we are born. We don't learn them. They are just there. Think about a tiny baby. They know how to suckle for milk, how to grip your finger tightly, or how to cry when they need something. No one teaches them these things. These are instincts at work. Ancient wisdom coded right into our very being. These are not thoughts we choose to have. They are older than words, older than history books. For thousands and thousands of years, humans and animals have relied on these powerful, unseen forces. It's like our ancestors passed down secret instructions, not through stories, but through our very bodies. It's almost as if a deep, universal knowledge lives within us, guiding us, even when our minds are not aware of it. Imagine you're walking home alone at night. Suddenly, a strange sound makes the hairs on your arms stand up. Your heart beats faster. You don't see anything, but every part of you screams danger. You didn't decide to feel scared. Your body just reacted. This is your fight or flight instinct, kicking in to protect you. It's a survival mechanism, a warning system that's been honed over millions of years, telling you to either face the threat or run away from it. Or consider a time you saw someone in trouble. Maybe a friend slipped and was about to fall hard. Did you think about it? Or did your hand just shoot out to grab them? Without a second of hesitation. That quick, selfless act often comes from a deep protective instinct, a drive to help those around us, especially people we care about. It's not a logical calculation. It's an urge from deep within. Think about how a dog will bark to protect its home, or how a bird builds a perfect nest without ever being taught. These actions are driven by something ancient and automatic. We can study these instincts. Scientists can see how our brains light up, how our bodies react. They can map the pathways and describe the chemicals involved. But here's the problem. We can't truly explain why they exist in such a profound, automatic way. We can describe the wiring, but we can't fully grasp the unseen force that throws the switch. It's like trying to understand the wind by only looking at the leaves it blows. The wind itself remains unseen, a fundamental force. We might understand how it works in terms of physics, but not the deeper why it's there at all. And that's why it matters. These instincts are a part of us that we will likely never fully understand. They are quiet whispers from our ancient past, guiding us, protecting us, and shaping who we are, often without our knowing it. They show us that there are forces at work within us that go beyond our conscious thoughts, beyond our logic, beyond even our deepest science. They remind us that we are connected to something vast and mysterious, a deep current of life that flows through all living things. It makes you wonder, doesn't it? What other secrets do our own bodies hold, hidden just beneath the surface of our awareness, forever just out of reach? Why some things just are, and we don't know why. Have you ever looked at something completely normal, something you see every day, and suddenly thought, but why is it like that? Not just how it works, but why it's fundamentally that way to begin with. Like, why does time only move forward? Or why is the sky blue? We can explain how light scatters to make the sky look blue, but why do the rules of light and scattering exist at all? This is a question about things that simply are, without a deeper why that we can point to. Here's the thing. Some parts of our world, and even the universe, just seem to be. They are fundamental building blocks or basic rules that don't appear to have an explanation beyond themselves. Think of it like this. If you build a house, you need a foundation. You can ask why the walls are here, or why the roof is shaped that way. And there are reasons. But why is there a foundation at all? Because without it, you can't build. The foundation simply is the starting point. For centuries, thinkers and philosophers have bumped up against these kinds of questions. Long ago, people like the ancient Greeks wondered about the most basic nature of reality. They weren't asking how a particular machine worked, but rather, why is there something instead of nothing? Why do things exist in the first place? They tried to find the ultimate reasons for everything, but eventually, you get to a point where the why seems to disappear. It's like asking why a single drop of water is wet. It just is. That's its nature. In science, we see this all the time. Take gravity, for instance. Isaac Newton, a brilliant scientist, observed that an apple falls from a tree. He figured out how gravity works, writing down mathematical rules that let us predict how things will fall or how planets will orbit. But even today, after all our amazing discoveries, we still don't know the deepest why behind gravity. Why does matter pull on other matter? It just does. It's a fundamental force of nature, a basic rule etched into the fabric of the universe. We can describe it, measure it, and use it, but the ultimate why remains a mystery. Think about a simple feeling. Why does the color red often make us feel a sense of warning or energy? Why does a sad song sometimes make us feel like crying, even if we're not sad about anything specific in our lives? We can study the brain and see which parts light up, and we can look at human history and culture. But the deepest why behind that feeling itself, that raw experience, is incredibly hard to pin down. It just is how many of us are wired. These are like basic programs in our human operating system. It can feel a little strange to think about things that have no further explanation. It goes against our natural urge to always find a reason, to always understand. But maybe that's the point. Maybe some things aren't meant to be explained away. Maybe they are the very ground we stand on, the basic colors in the paint box of existence. Accepting that some things just are doesn't mean we stop being curious. Instead, it can open up a different kind of wonder. It reminds us that there's a deep, unspoken mystery at the heart of everything, and sometimes, simply marveling at that mystery is understanding enough. It's a quiet acceptance of the universe's most beautiful secrets, the ones it keeps just beyond our reach. The nature of true love. We talk about love a lot. We see it in movies, hear it in songs, and feel it for our friends and family. But what about true love? Is it just a powerful feeling, like a sudden crush that makes your heart race? Or is there something deeper, something more lasting, that humanity is always trying to figure out? For thousands of years, people have tried to understand this big idea. It's not just a crush, and it's more than just liking someone a lot. True love, many wise people believe, is a deep, lasting connection. It's where you truly care about someone else's well-being, sometimes even more than your own. It's a choice you make every single day, not just a feeling you fall into. It's about commitment and wanting the best for the other person, always. Ancient Greek philosophers had different words for love, showing just how complex it is. They talked about eros, which is passionate, romantic love. This is the kind you often see in fairy tales or dramatic movies, full of excitement and longing. Then there was philia, which is the deep bond you share with friends. It's built on loyalty, shared interests, and mutual respect. You trust your friends, and you enjoy spending time with them. But the one that comes closest to what we might call true love is agape. Agape is a selfless love. It's about wanting the best for someone, without expecting anything back from them. It's about giving, supporting, and understanding, purely for their benefit. It doesn't ask, "What's in it for me?" Instead, it asks, "How can I help you grow and be happy?" Think about a strong, healthy tree. Its roots go deep into the ground, holding it firm, even through the wildest storms. Those roots aren't just taking nutrients. They are anchoring the tree, supporting its growth, allowing its branches to reach high for the sky. True love is a bit like those roots. It's not just about what you get from someone, like shade on a hot day or a nice fruit. It's about how deeply you support them, how you help them grow, and how you stay connected even when things are tough. Or think about a best friend. A true best friend isn't just someone you have fun with. They stand by you, Not only when things are easy and exciting, but also when you've made a mistake or are feeling really sad and confused. They might not always agree with every single thing you do, but they listen to you. They don't judge you harshly. They want you to be truly okay, deeply okay. Sometimes, that means having a difficult conversation with you, or just being there quietly when you need some space. This kind of loyalty, this deep wish for another person's well-being, that's a glimpse into what true love can be. It's not about needing them to make you happy, but about cherishing them and wanting the best for them, always. It means choosing to be kind, choosing to listen, and choosing to forgive, even when it's hard. It's about understanding that the other person is also a complex human being, with their own worries, their own dreams, and their own bad days. It's a journey of learning and growing together, rather than just a sudden, perfect spark that magically lasts forever without any effort. So, true love isn't just a magical feeling that sweeps you off your feet, making everything perfect in an instant. It's far deeper than that. It's a quiet promise, a steady light, something you build and choose every single day. It's about seeing someone completely their strengths, their quirks, their flaws, and still choosing to care for them deeply. It's about supporting their journey, even when it takes them down paths you don't fully understand. It's a powerful, patient force that makes the world feel more connected, more meaningful, and less lonely. And maybe, truly understanding this kind of love, the selfless, growing, enduring kind, is one of humanity's most beautiful, ongoing lessons. It's a mystery we keep exploring, one heart at a time. Can we ever travel faster than light? Have you ever looked up at the night sky, at all those twinkling stars, and wished you could visit them? Maybe you've seen movies where spaceships zip across galaxies in seconds. It makes you wonder, can we ever truly travel faster than light? Is it just a dream? Or is it something we might figure out one day? Here's the thing. Light moves incredibly fast. We're talking about 186,000 miles per second. That's so fast, light from the sun takes just over 8 minutes to reach us, but light from the nearest star beyond our sun takes over 4 years. It's the ultimate speed limit in the universe, a cosmic rule. And a famous scientist named Albert Einstein discovered a deep truth about this. He found that nothing with actual mass, no person, no spaceship, no planet, can ever reach the speed of light, let alone go faster. Why is that? Well, it gets a bit mind-bending, but here's what he said. As anything with mass goes faster, it also gets heavier. Not just a little heavier, but much, much heavier. If you somehow managed to get close to the speed of light, your spaceship would become so heavy it would need an impossible amount of energy to go even a tiny bit faster. Think of it like trying to push a heavy car. At first, it's hard, but you can get it moving. But imagine that car getting heavier and heavier with every tiny push until it weighs as much as a mountain. You just wouldn't be able to move it anymore. That's what happens to a spaceship trying to reach light speed. It becomes infinitely heavy, needing infinite energy, which simply isn't possible. People have always dreamed of breaking limits. For a long time, humans thought flying was impossible. Then we figured out airplanes. We once believed nothing could go faster than sound. And now jets do it easily. But light speed seems different. It's not just about building a better engine or finding a new way to fly. It's about a fundamental rule of the universe itself. Like how 2 + 2 always equals 4. If we could go faster than light, strange things would happen to time itself. You could, in a way, travel into the past, and that just doesn't seem to fit with how the universe works. So, while it's fun to imagine, traveling faster than light is something that, according to our deepest understanding of physics, just can't happen. It's like trying to draw a square circle. It sounds cool, but the very definition of a square and a circle makes it impossible to be both at the same time. And that's why it matters. This cosmic speed limit reminds us that there are rules to our universe. Grand truths that we are only just beginning to grasp. It means the stars and galaxies, while reachable in our thoughts and through our telescopes, will remain incredibly far away for actual travel. But here's the quiet beauty in that. Knowing this limit doesn't make the universe less wonderful. Instead, it makes us think about its vastness in a new way. It helps us appreciate the light that travels across unimaginable distances to reach our eyes, connecting us to events that happened millions of years ago. It teaches us a humble lesson. Sometimes, the greatest adventure is understanding the rules of the game we're playing, rather than trying to break them. Is the universe truly endless? When you look up at the night sky, past the streetlights and the tall buildings, what do you see? Tiny points of light, millions of them. Does it ever make you wonder how far those lights go? Do they just keep going, forever and ever? Or is there an edge somewhere? This is one of the biggest questions humanity has ever asked. Is the universe truly endless? It's a really deep thought. For a long time, people just imagined the stars were little holes in a black curtain. But we know so much more now. Here's the thing. When we talk about the universe, we often mean two different parts. There's the part we can see, and then there's the universe itself. The part we can see is called the observable universe. Think of it like this. Light takes time to travel. A lot of time. When you see a star in the sky, you're not seeing it as it is right now. You're seeing it as it was years ago, or even millions or billions of years ago. The light from that star has been traveling all that time to reach your eyes. So, if a star is so far away that its light hasn't had enough time to reach us since the universe began, we simply can't see it. It's beyond our observable universe. It's like listening to a really quiet whisper from far away. If the whisper is too far, or if it hasn't had enough time to travel to you, you won't hear it. And here's another strange part. The universe itself isn't sitting still. It's actually stretching, getting bigger all the time. Imagine blowing up a balloon. The surface of the balloon gets bigger, right? That's kind of what the universe is doing, but in every direction. This means that space itself is expanding, carrying galaxies further and further apart. So, some parts of the universe are moving away from us faster than light can travel to us, making them impossible to ever see. For thousands of years, people thought Earth was the center of everything. Then we realized the sun was the center of our solar system. Then we learned our Sunday was just one of billions of stars in a huge galaxy called the Milky Way. And then we discovered there are billions and billions of other galaxies, each with billions of stars. Every time we look closer, the universe seemed to get bigger. It keeps challenging our ideas of what's big and what's small. It makes you feel very tiny, but also very connected to something huge. Think about being on a vast ocean. You're in a boat, and you look out. All you see is water stretching to the horizon in every direction. You can't see an edge. Does that mean the ocean is truly endless? No, not really. It just means you can't see the edges from where you are. The Earth is round, and the ocean eventually connects back to itself or meets land. The universe is a bit like that, but much, much more complex. We can't see an edge, but that doesn't automatically mean there isn't one, or that it just goes on forever. Maybe it's like the surface of a giant, bending shape that has no edge, but is still limited in size, like the surface of a ball. Or maybe it truly does go on forever, we just don't know for sure. The truth is, we don't have a final answer yet. We can see so far, but beyond that, it's a mystery. Scientists are still working on it, using powerful telescopes and complex math. It's a question that reminds us how much there is still to learn, how much is beyond our current understanding. And that's okay. Sometimes, the most beautiful thing isn't having all the answers, but living with the wonder of the questions. It's about feeling small in the face of something so immense, and realizing that this very feeling of wonder is a part of being human. It makes us curious. It makes us want to explore and understand. So, the next time you look at the stars, let that endless feeling of wonder fill you. Because even if the universe does have an end, our questions about it, and our desire to understand, might just be endless too. The question of other dimensions. Have you ever looked at the world around you and wondered if there's more to it than meets the eye? We move forward and back, side to side, up and down. This is our world, a three-dimensional place. But what if there are other directions we can't see? Other spaces we can't reach? Other dimensions beyond our normal understanding? For a long time, people mostly just accepted the world as it seemed. But as science grew, some began to wonder, could there be more to reality than just our everyday three dimensions? This isn't just about faraway places. It's about different ways to exist. Levels of reality right here that we simply aren't built to sense. Think about it like this. Imagine a world with only two dimensions, like a drawing on paper. The creatures living there, let's call them Flatlanderscan, only move forward, backward, left, or right. They understand length and width. They would see everything as flat shapes. They would have no idea what up or down means. It just isn't part of their experience. Now imagine if you, a three-dimensional person, touched their paper. They wouldn't see your whole finger. They would only see a small circle appear, then grow larger as more of your finger touched their world, and then shrink back to a point as you lifted it away. To them, your finger might seem like a mysterious, changing shape that suddenly appears and disappears. They couldn't truly grasp the idea of your whole hand, or you as a full human, because they don't have the up dimension to understand it. Here's the thing. Just as we easily see the two-dimensional world from our three-dimensional one, what if there are beings or realities that exist in 4, 5, or even more dimensions? And what if, to them, our entire three-dimensional universe looks just like that flat piece of paper? They might see us as strange, shifting shadows, unable to truly grasp our full form or the full space we occupy. It's a humbling thought, isn't it? For centuries, thinkers and scientists have played with these ideas. Early philosophers might have imagined spirit worlds beyond our sight, a simple, early idea of other dimensions. Later, mathematicians realized they could write equations that worked perfectly well with 4, 5, or even 10 dimensions, even if we couldn't picture them. It became less about magic and more about pure possibility. Today, some advanced theories in physics, like string theory, suggest there might actually be many more dimensions, perhaps as many as 10 or 11. These extra dimensions aren't just empty space. They're thought to be tiny, curled up, almost invisible to us, woven into the very fabric of reality. Or maybe they are vast and just beyond our perception, like radio waves we can't see or touch. We can't prove these extra dimensions are real with our current tools. We can't reach out and touch the fifth dimension, or peek around the corner of the seventh. But the very idea forces us to rethink what reality is. It whispers that our understanding of the universe might be very limited, like those Flatlanders on their paper, only seeing a small part of a much grander picture. Maybe understanding other dimensions isn't about finding a new place to visit. Maybe it's about expanding our minds to accept that the universe is far stranger, far more complex, and more mysterious than we could ever imagine. It reminds us that there are still so many secrets hidden in plain sight, waiting to be discovered, or perhaps forever out of reach. And that deep mystery, that endless wonder, is part of what makes our universe so beautiful and so humbling to be a part of. What happens after we die? Have you ever just stopped, looked out into the distance, and really wondered, what happens after we die? It's a question that has puzzled people for all of history, long before any of us were even born. When a person dies, their body stops working, their heart doesn't beat anymore, their lungs don't breathe, and their brain activity ends. That much science can tell us. But what about the part of them that laughed, that thought, that loved? What about their thoughts, their feelings, their very self? That's the real mystery. For thousands of years, people around the world have come up with different ideas about what happens next. Some cultures believe in an afterlife, like a heaven or a spiritual world where a part of us continues to live. Others believe in reincarnation, where our spirit or soul comes back to life in a new body, perhaps to learn new lessons. And then there are many who believe that when we die, it's simply the end, like a movie finishing or a light being turned off. There are no more thoughts, no more feelings, just nothingness. The interesting thing is, no one who has truly died has ever come back to tell us for sure. We can read about different beliefs, and we can think about them, but we can't truly know. It's like being completely lost in a really good book. You're so caught up in the story, you feel like you're there with the characters. You know their hopes, their fears, their journey. But then, you reach the very last page. The story ends. The book closes. Where do those characters go? Do they just stop existing the moment you close the cover? Or do they live on in your memory, in the way they changed how you think or feel? Our own lives are kind of like that book. We live our stories, we experience so much, and then our story on Earth has an end. But what happens after that final page? Does our consciousness, that part of us that makes us us, simply disappear, or does it go somewhere? Or become something else entirely? Science can explain so much about the physical world and how our bodies work, but it hasn't given us a definite answer to this. It's a boundary that humanity simply can't cross and then report back on with a clear explanation. And that's okay. It's a thought that can feel big and even a little heavy sometimes, especially if you've experienced losing someone you care about. It can make you feel small in the face of such a huge unknown. But this big question, this deep mystery, is shared by every single person who has ever lived, or whoever will. It connects us all in a strange and powerful way. Maybe the answer isn't something we are meant to fully understand while we are alive. Maybe the very mystery of what comes after helps us appreciate what's happening now. It reminds us that our time here, this breath, this moment, is precious. It encourages us to live fully, to be kind to ourselves and others, to learn new things, and to truly experience the world around us. Because these experiences, right here, right now, are truly ours. The unknown isn't necessarily something to fear, but something that adds a deep, quiet wonder to the amazing journey of being alive. The strange world of numbers. Think about numbers for a moment. You use them every day, right? To count your money, tell time, measure how tall you are, or figure out how many followers you have online. Numbers seem so simple, so solid, so real. But what if they're not? What if the very idea of a number holds secrets we can't quite grasp? We often think of numbers as tools we invented, like hammers or pencils. We needed a way to count things, so we made up these symbols and rules. 1 apple, 2 apples, 3 apples. It feels very human, very practical. But some people, for thousands of years, have wondered if numbers are more than just our inventions. What if they are fundamental truths about the universe itself, waiting for us to discover them, much like we discover new planets or hidden laws of physics? Imagine a number like pi. You might remember it from math class, the number we use to figure out the distance around a circle. It starts 3.14159, and it just keeps going, forever. Its digits never repeat in a pattern, and no one has ever found an end to it, even with the most powerful computers. It's an endless string of digits, a mystery wrapped in a circle. We can use it, we can calculate with it, but can we truly understand an infinite number? How can something go on forever, without ever repeating or ending? It's like trying to picture a journey that never stops, not even for a second, across an endless landscape. This isn't just about pi. It's about the very concept of infinity itself, or even the concept of zero. Zero means nothing, right? But it's also incredibly powerful. Before ancient civilizations invented zero, doing complex math was almost impossible. Zero isn't just nothing. It's a placeholder, a starting point, a balance. It's nothing, but it's essential to everything. How can something that represents nothing be so vital and so hard to truly define without a paradox? Here's the thing. Numbers are like the hidden language of the universe. From the way planets orbit the sun, to the patterns on a sunflower, to the tiny particles that make up everything around us, numbers are there. They describe the very fabric of reality. But we only understand a small part of this language. We can use the numbers, we can see their effects, but their true nature, where they come from, or why they behave the way they do, remains a mystery. It makes you wonder, doesn't it? Are numbers just marks on a page or sounds we make? Or are they something deeper, something that exists independently of us, holding the secrets to everything? Maybe they are a hint that the universe is far more organized and complex than we can ever fully grasp. And that's why, even though we use them constantly, numbers might be one of those strange, beautiful things humanity will never truly, completely understand. They simply are, and they're being hints at a vastness beyond our reach. Why humans are so curious? Have you ever stopped to think about why we humans are always asking questions? Why do we feel that constant itch to know more, to dig deeper, to understand things that seem just beyond our reach? It's a very human thing, this feeling of curiosity, It's like a quiet engine always running inside us, pushing us to explore, to learn, and to figure things out. At its core, curiosity is a powerful urge to know. It's the feeling that there's a gap in your knowledge, a blank space on your mental map, and you just have to fill it in. Think about a baby, barely able to walk, but already reaching for everything, touching it, putting it in their mouth. That's pure curiosity. They are trying to understand their world, one touch, one taste at a time. This simple urge to know never really leaves us. It just changes as we grow. For thousands of years, this deep desire to understand has been a huge part of what makes us human. Early people, standing under a vast night sky, must have wondered about the stars. What were they? Were they tiny lights? Or something much bigger, much farther away? This wonder led to astronomy, to navigation, to trying to map the heavens. Or when they saw a new animal, they didn't just walk away. They wondered, is it dangerous? Is it food? Where does it live? This drive to know helped them survive and build communities. It wasn't just about finding food or shelter. It was also about the deep need to make sense of their world, to connect the dots. Here's an example you might recognize. Think about when your phone or computer isn't working right. You don't just give up. You might try restarting it, or looking up solutions online, or asking someone who knows more. That need to fix it, to understand why it's not working. That's curiosity. Or imagine you're watching a movie and a character does something confusing. You don't just accept it. You wonder, why did they do that? What's their story? You're searching for understanding, for the deeper reasons. It's not just about what happened, but why it happened. This drive isn't just about simple facts. It's about something bigger. It's about trying to grasp the meaning behind things. It's about the big questions that don't have easy answers. Why are we here? What happens after we die? Are we alone in the universe? These are the kinds of questions that have puzzled humanity for all of history. And even though we might never fully understand them, the very act of asking, of searching for answers, makes us who we are. So, this powerful human curiosity, this constant questioning, is what makes us unique. It's a fundamental part of our journey on Earth. It pushes us to explore the unknown, to invent new things, and to always look beyond what we already know. It's okay that some mysteries might never be completely solved. Maybe the point isn't always finding the final answer. Maybe the real beauty is in the endless journey of asking, wondering, and reaching for just a little more understanding. It's in the quiet hum of that engine inside us, always pushing us forward into the mystery. The silence of the vast universe. Have you ever looked up at the night sky, really looked, and wondered if anyone else is out there? Not just on Earth, but in the millions, billions of stars you see, and the ones you can't see. It's a pretty natural thought. We live on one planet, orbiting one star, in one galaxy. But the universe is so much bigger than that. It's almost impossible to imagine how big. Scientists estimate there are more stars in the universe than grains of sand on all the beaches on Earth. And many of those stars likely have planets orbiting them, just like our sun does. So, if there are so many stars and so many planets, it seems like life should be common, right? It seems like some of that life should have developed intelligence, built big cities, and maybe even started traveling between stars. We've been sending out signals, like radio waves, for about 100 years now. If someone else out there was doing the same thing, or even more advanced, shouldn't we have heard something by now? This is the core of what we call the silence of the vast universe. It's also often called the Fermi paradox, named after a smart scientist named Enrico Fermi. One day, he just simply asked, "Where is everybody?" He was talking about aliens. He meant, if space is so big and old, and life could pop up in many places, why haven't we seen any clear signs of it? Why is it so quiet out there? Think about it like this. Imagine you're at home, and your parents told you they've invited hundreds of kids from all over town to a giant party at your house. You get ready, you set out snacks, you turn on music, you expect the house to be full of laughter and talking, but then the doorbell rings, and no one is there. You wait and wait, but no one ever shows up. The house stays completely empty and quiet. The universe, in a way, feels like that empty party. It's so huge, so ready for life, but we hear nothing. No chatter, no music, no footsteps, just endless silence. This isn't just about looking for little green men. It's a deep question about our place in everything. Does it mean life is super rare? Maybe even that Earth is incredibly special and unique? Or does it mean that intelligent life, when it does appear, doesn't last very long? Maybe civilizations grow, use up their planet's resources, and then disappear before they can ever reach out to the stars. That's a scary thought. Or maybe, and this is another idea, there's something about how we're listening or what we're looking for that's just plain wrong. Maybe alien life is so different from us that we wouldn't even recognize their signals. Or maybe they communicate in ways we can't even imagine yet. It's like trying to listen for a whisper when you're expecting a shout. The silence is a mystery, a big, quiet question mark hanging over our heads as we look at the stars. It makes us feel very small, but also makes us wonder about huge, important things. It forces us to think about what makes life possible, what makes intelligence grow, and what might happen to civilizations, including our own, in the very long run. It's a mystery that reminds us how much we still have to learn, and how much wonder there is in the things we don't understand, especially when that understanding feels so far away, hidden in the deep, quiet darkness between the stars. It's a silence that speaks volumes about our journey to find our place in the cosmos. The unexplained power of music. Have you ever stopped to think about why a certain song can make you feel so much? Why a melody can change your mood in an instant, lifting you up when you're down, or calming you when you're anxious? It's not just a collection of sounds. It's something deeper, something that touches us in ways we can't quite explain, almost like magic. Music is, in its simplest form, organized sound. But here's the thing. It affects our emotions, our bodies, and even our memories in powerful, mysterious ways. We don't just hear music, we feel it. It can make our hearts beat faster, give us goosebumps, or bring tears to our eyes, even when there are no words to explain why. It's like a secret language that everyone understands, no matter where they come from or what language they speak. Think about people from long, long ago, even before recorded history. They didn't have writing, but they had music. Ancient humans used drums, flutes made of bone, and their own voices to create sounds. They used music in their ceremonies, for storytelling around the fire, for healing, and to connect with each other. Philosophers like Plato, thousands of years ago, talked about music's deep power to shape our character and influence society. They knew it wasn't just entertainment. It was something vital, something fundamental to being human. But they couldn't fully explain how. It worked its magic. So, why does a sad song make you feel like crying, even if your day was perfectly fine? Or why does an upbeat song make you want to dance, even when you're tired? It's not just the words, if there are any. It's the rhythm, the pitch, the way different notes blend together. Imagine being at a basketball game. When the team is about to score, the crowd gets loud, and often, a certain kind of energetic music plays. That music makes everyone feel more excited, more hopeful, and more united. It helps the players too, getting them pumped up. Or think about a scary movie. The music isn't just background noise. It's what makes your heart pound and gives you chills, even before anything truly frightening happens on screen. Science tells us that music can do amazing things to our brains. It can release chemicals like dopamine, which makes us feel good. It can make different parts of our brain light up, connecting areas related to memory, emotion, and movement. People who have lost their ability to speak can sometimes still sing words. Music can help patients remember things they thought they'd forgotten. It's as if music taps into a part of us that words can't reach. But the how of this deep connection, why a specific sequence of sounds creates such profound feelings, still puzzles us. We can observe its effects, but the fundamental reason remains out of reach, and that's why it matters. Music is a beautiful reminder that there are powerful, unseen forces at work in the world and within us. It's a mystery that continues to inspire us, comfort us, and connect us, showing us that some of life's most profound experiences might forever remain just beyond our full understanding, echoing like a tune we feel more than we can define. The true logic behind our fears. Have you ever felt your heart pound, your palms get sweaty, or a sudden chill run down your spine. Maybe it was before a big test, or when you saw a spider, or when you heard a strange noise in the dark. It feels like fear just takes over. But what if I told you that even these powerful feelings have a kind of logic, a deep purpose built into us? It's true. Our fears, even the ones that seem to make no sense, are actually ancient tools designed to keep us safe. Think of fear as your body's built-in alarm system. It's not just a feeling. It's a quick burst of energy and focus, a signal that tells you something might be dangerous. This system isn't new. It's been developing inside humans for millions of years. Imagine our ancestors living in wild places. They needed to react instantly to a rustle in the bushes, a shadow moving quickly, or a sudden loud sound. If they didn't feel fear, if they didn't quickly run or get ready to fight, they wouldn't have survived. And so, the ones who had this strong fear response were the ones who lived long enough to have children. That's how fear got passed down to us, wired right into our brains. Here's the thing. Our modern world is very different from those ancient times. There are fewer saber-toothed tigers hiding in the tall grass. But our fear system hasn't really updated itself. It still works on those old rules. So, when you're about to give a presentation in class, your brain might react as if you're facing a real threat, even though you're perfectly safe. Your heart races. Your voice might shake. This is your ancient alarm system going off in a situation that isn't truly life-threatening. It's a misfire, in a way, but it's still trying to protect you from something it sees as dangerous, like embarrassment or failure. Consider a common fear, like the fear of heights. For many, just looking down from a tall building can make their stomachs drop. Is the building going to fall? Probably not, but your brain connects that high place with the very real danger of falling. So, it sends an alarm. It's a very logical response when you think about it from a survival point of view. Or, what about the fear of the unknown? That's a big one. It's why dark rooms can feel scarier than brightly lit ones. Or why we sometimes worry about things we can't see or predict. Our brains prefer to know what's coming. When we don't, when something is completely beyond our understanding, that ancient alarm system kicks in, telling us to be careful, to be alert. So, while fear can sometimes feel overwhelming, it's not just a random emotion. It's a message, a powerful signal from our past that still tries to guide us. It reminds us of limits, of what we value, and of the vast, mysterious things we don't yet grasp. Even when fear feels illogical, at its core, it holds a deep, quiet wisdom to keep us safe, to make us cautious, and to help us navigate a world that still holds so many secrets we may never fully understand. And in that way, fear isn't something to always fight, but sometimes something to simply understand. The riddle of evolution's next step. Have you ever stopped to wonder what comes next? Not just for you, but for all of humanity. It's a big question, a deep mystery. We often think about our past, how we got here, how life started small and became all the amazing creatures we see today. But what about tomorrow, 1,000,000 years from now? What will humanity become? What is the next step in our story? Here's the thing. Evolution is how living things change over very long periods. It's like nature's slow, ongoing art project. Think about it. Our ancient ancestors didn't have big brains like ours. They didn't stand on 2 feet. They didn't talk in complex languages. They were different. Over millions of years, tiny changes happened, generation after generation. Animals with helpful traits were more likely to live and have babies. Those babies inherited those traits. This process, natural selection, is a gentle, constant nudge. It's why polar bears have thick fur in the Arctic, and fish have gills to breathe underwater. They changed to fit their world. So, if we understand how we got here, why can't we guess where we're going? Why is the next step of evolution such a deep riddle? Evolution isn't a train heading to a planned destination. It has no goal. It's not trying to make us smarter, or stronger, or able to fly. Instead, it's a constant reaction to what's happening right now in the world. Imagine trying to predict the weather 10 years from now. Impossible, right? Too many small things could happen. A tiny wind change or ocean shift could make the whole prediction wrong. Evolution works like that. It's shaped by random changes in our genes and by the environment. If the world gets warmer, or a new disease appears, or we invent new technology, that could slowly change what traits are helpful for survival. Think of it like a very long game of whisper down the lane, but with bodies instead of words. Each person is a generation. When the whisper, our genes, gets passed on, sometimes a tiny mistake or change happens. Most times, these changes don't do much, but sometimes, a change makes a creature a little better at living. Maybe they run faster, or see better, or digest new food. That small advantage helps them survive and pass on that changed whisper. Over millions of years, these tiny whispers add up to big changes. But here's the problem. We don't know what the lane will look like in a million years, or what challenges will appear. Will Earth be hotter, colder, or will we be living on other planets? Evolution's path isn't a straight line up a mountain. It's more like a sprawling tree, constantly branching, adapting to light and soil. We are just one branch on that enormous tree. We see where we came from, but not the leaves that will grow on future branches. So, the riddle of evolution's next step stays a riddle. It reminds us we are part of something much bigger. We aren't finished products. We are part of a living story, unfolding one tiny, unpredictable change at a time. This mystery isn't scary. It's beautiful. It means life is always adapting, always finding new ways to be. We might never understand what humanity will look like a million years from now, or if we will exist in a recognizable form, but knowing the process continues, that life is always moving forward, fills us with quiet wonder. It connects us to every living thing, from the smallest bug to the tallest tree, all part of this incredible journey of change. We are living examples of this process. And the story continues, unknown and magnificent. Why do we laugh and cry? Have you ever really stopped to think about laughter and tears? These are two of the most powerful things our bodies do, sometimes without us even trying. One moment you're giggling so hard your stomach hurts, the next, tears are streaming down your face. Maybe even when you're happy. Why do we, as humans, do this? It's a deep question, one people have wondered about for a very long time. Let's start with laughter. Think about the last time you laughed really hard. Maybe a friend told a silly joke that didn't make much sense, or someone tripped over their own feet in a funny way but didn't get hurt. Laughter often comes from surprise, from something unexpected that breaks our normal way of thinking, but in a safe way. It's like our brains suddenly realize something is a little bit off, but it's okay. So, we make this strange, joyful sound. It's not just a sound, though. Laughter is also a powerful way we connect with other people. When you laugh with someone, it's like you're saying, "Hey, I get it too. We're together in this moment." It builds bridges between us. It helps us feel safe, happy, and part of a group. Some thinkers in history even believed laughter was a way to feel superior to something or someone. But mostly, it's about shared joy and connection. Now, think about tears. Crying is often seen as a sign of sadness, and it definitely is. When something truly painful happens, like losing a pet or feeling really disappointed, tears are a natural response. They are like a release valve for huge, heavy emotions. But here's the thing, we don't just cry when we're sad. Sometimes, tears come when we're incredibly happy, like when a team wins a championship after a long struggle, or when you're so relieved about something, like getting a good grade on a test you were worried about. These tears are also a way to let out intense feelings that are too big for words. Our bodies physically react to these overwhelming emotions, no matter if they're good or bad. For a long time, people have thought about why tears exist. Some old ideas suggested they literally cleaned the body of bad humors or liquids. But today, we understand it's more about emotions. Crying is a biological process that helps us deal with strong feelings. When we cry, our bodies release certain chemicals, which can actually help us feel a little calmer afterwards. And just like laughter, crying can be a way to connect. When you see someone crying, you often feel a natural pull to offer comfort. It's a signal to others that you might need help or support, and it brings people closer. Think about it like this. Your emotions are so big, they need a physical way to show up. a way to be shared. So, both laughter and tears are like special languages our bodies speak. They are ancient, built right into what it means to be human. They remind us that we are emotional beings, full of joy and sorrow, surprise and relief, and perhaps the mystery of why these reactions exist so powerfully, why they can overwhelm us in an instant, simply reminds us how deep and complex the human experience truly is. They are part of what makes us, us, the smallest things in the universe. Have you ever looked at a tiny grain of sand, really focused on how small it is, and then thought, what is that made of? Or maybe, how far down does small even go? It's easy to think of big things, like planets and stars. But the universe is just as mysterious, maybe even more so, when you shrink things down to their absolute smallest. Here's the thing. Everything you see, touch, and feel is made of incredibly tiny pieces. For a long time, people thought the smallest piece was an atom. The word atom actually comes from an old Greek word meaning uncuttable or indivisible. Around 2,500 years ago, a thinker named Democritus wondered if you could keep cutting something in half forever. He decided no. Eventually, you'd reach a piece so tiny it couldn't be cut anymore. He called that piece an atom. For thousands of years, that idea made sense. But then, scientists found out that atoms aren't actually uncuttable. They're like miniature solar systems, with even smaller bits inside them. Think of it like this. Your house is made of bricks, but each brick is made of tiny bits of clay and other stuff. Atoms are made of even smaller parts, like protons, neutrons, and electrons. And then, it gets even weirder. Those protons and neutrons, they're made of even smaller particles called quarks. And electrons? They're thought to be fundamental, meaning we haven't found anything smaller inside them yet. So, we have these quarks and electrons, and other particles like them. They are truly unbelievably tiny. We can't see them, not even with the most powerful microscopes. We know they exist because of really complex experiments, like smashing them together in huge machines and watching what happens. And here's where it gets mind-bending, where humanity hits a wall in its understanding. These particles don't behave like anything we're used to. Imagine trying to catch a bouncy ball, but sometimes it just vanishes and then reappears somewhere else instantly. Or imagine trying to measure a car's speed and its exact location at the same time, but the act of measuring one makes the other impossible to know for sure. That's a bit like how things work in the world of the super small. Particles can be in two places at once, or instantly linked to another particle no matter how far apart they are. They don't have a clear position or speed in the way a car does. It's like they exist in a cloud of possibilities until we try to look at them. This realm of the smallest things is called quantum mechanics, and it's a completely different rulebook from the one we use for everyday life. We can write down math equations that perfectly predict what these particles will do, but we can't truly understand why they act that way. Why does looking at a particle change it? Why are things so fuzzy and uncertain at this level? It's like the universe is whispering a secret language we can perfectly translate, but don't actually comprehend. And that's why it matters. This deep mystery reminds us that our human brains, as amazing as they are, might just not be wired to grasp everything about reality. Even when we break things down to their very tiniest components, we find more questions than answers. It shows us that there's still so much wonder and awe in the universe, even in the parts we think we've figured out. We learn more and more, but the ultimate why behind the smallest pieces of everything often remains just beyond our reach, a gentle whisper of the unknown. The biggest questions we still have. Have you ever looked up at the night sky, maybe on a really clear night when you can see so many stars, and just felt incredibly small? Like really small? And then, did your mind start to buzz with questions? Questions about how big it all is, or what else might be out there? Those big questions, the ones that make your brain tingle a little, are what we're talking about. These are the deepest mysteries humanity has faced for thousands of years, and we still don't have solid answers for them. They are the biggest puzzles that stay unsolved, no matter how smart we get. Think about it this way. Imagine you're playing a video game, like a really big, open-world game. You know the rules, you know the goals, But what if you started to wonder, who made this game? And why? Is there an outside to this game world? That's a bit like the kind of questions we ask about our own reality. One of the biggest questions is about the universe itself. Where did everything come from? Scientists talk about the Big Bang, the moment everything began. But what was before that? Was there nothing? How can nothing turn into everything? And how big is the universe really? We know it's constantly expanding, getting bigger all the time. But if it's expanding, what is it expanding into? Is there an edge? And if there is, what's on the other side of that edge? This question has puzzled thinkers from ancient Greece, who looked at the stars and wondered about their meaning, all the way to modern scientists with giant telescopes. We still don't know the answers. Then there's the mystery of consciousness. That's a big word, but it just means your ability to be aware, to think, to feel emotions, to know that you are you. How does a bunch of brain cells, just squishy tissue and electrical signals, create something as amazing as your thoughts, your feelings, your memories? When you dream, those dreams feel so real, right? But they are just happening in your mind. Is being awake any different? We understand a lot about how the brain works, like how different parts control different things, but we don't understand why we feel or think at all. A super advanced computer can do math faster than any human, but it doesn't feel happy or sad. Why do we? This is one of the deepest riddles in psychology and science. Another huge question is about life itself. Are we alone in the universe? With billions of galaxies and billions of stars in each galaxy, it seems unlikely that Earth is the only place with life. But so far, we haven't found any clear proof of aliens. If there is other life, what does it look like? Does it think like us? Could we ever communicate? And if we did, what would that even mean for us? And then there's the question that touches everyone. What is our purpose? Why are we here? Is there a reason for all of this existence? Or are we just here by chance? And what happens after we die? These are questions that religions and philosophies have tried to answer for centuries, offering comfort and guidance. But for each person, the answer often remains a very personal, often unspoken mystery. It's okay that we don't have all the answers. In fact, these unsolved mysteries are what make being human so amazing. They push us to keep exploring, to keep learning, and to keep wondering. They connect us to every person who has ever lived, because we all share this common experience of looking at the world and asking, why? It shows us that even with all our knowledge, there will always be a part of the universe that remains beautifully, wonderfully mysterious, inviting us to simply wonder. What is time, really? Have you ever really stopped and thought about time? Not just how it passes, but what it is. We all live inside it, watch it on clocks, measure our days by it. We say, I don't have enough time, or time flies when you're having fun. But what exactly is this invisible thing that seems to push us constantly forward, from one moment to the next? Here's the thing. Time isn't a physical object. You can't pick it up, or see it, or even feel it with your hands. It's more like a way we understand and organize everything that happens. Think about it this way. When you remember something that happened yesterday, you're placing it in the past. When you plan what you'll do tomorrow, you're thinking about the future. And the moment you're in right now, reading these words, that's the present. Time helps us put all these moments in order, one after the other. It's like a grand, silent story being told, and we're always on the next page. For thousands of years, people have wondered about time. Ancient thinkers, philosophers, and even early scientists looked at the sun, the moon, and the stars. They noticed how the days turned into nights, how the seasons changed. These repeating patterns helped them understand that things were always moving, always transforming. They saw time as a cycle, or sometimes as a straight line moving only forward. Even today, scientists are still trying to figure out if time is just a way for us to measure things, or if it's a real part of the universe, woven into the very fabric of space. Some theories even suggest that time might move differently for different people, depending on how fast they're moving or how strong the gravity is around them. That sounds wild, right? But it's what happens at super high speeds or near a black hole. For us, here on Earth, it feels pretty constant. But here's a mystery. Why does time feel different sometimes? Think about sitting in a really boring class. An hour can feel like forever, right? The clock barely moves. But then, when you're playing your favorite video game or hanging out with friends, hours can zoom by in what feels like minutes. This isn't because time itself is speeding up or slowing down. It's because of how our brains pay attention. When we're having fun, our brains are super engaged, and we lose track of the clock. When we're bored, our brains are looking for things to do, and every tick of the second hand becomes noticeable. So, our experience of time can be very different from the steady, unchanging march of the clock. Imagine time as a river. You are standing in a boat, and the current is always pushing you forward. You can look back at the parts of the river you've already floated through. That's the past. You can try to guess what the river looks like up ahead, beyond the next bend. That's the future. But you can only ever be in the exact spot you are right now, feeling the water flow past your boat. That's the present moment. The river never stops flowing. It doesn't wait for anyone. It doesn't slow down or speed up for your feelings. It just is. So, while we use clocks and calendars to measure time, and while scientists look at its role in the universe, the deepest part of time remains a mystery. We are always moving with it, but we can never truly hold it. We can't stop it, rewind it, or skip ahead. All we have is this very moment. And maybe that's the most profound truth about time. It's a constant reminder to be present, to notice the now, because it's the only part of the river we ever truly get to experience. It's a quiet invitation to live fully in the moment we are given. The unseen world of tiny life. Have you ever looked around, really looked, and wondered what else is here that you can't see? Not things far away in space, but right here, right now, all around you, even on you? It's a big question, and the answer is amazing. There's a whole universe of life so incredibly small we can't see it with our eyes alone. We're talking about tiny living things called microorganisms, or microbes. Think about bacteria, viruses, fungi, and other single-celled creatures. They are literally everywhere. On your skin, in the air you breathe, in every drop of water, every speck of dust. If you picked up a handful of soil, there would be more living things in it than all the people on Earth. This unseen world is buzzing with activity, constantly working, living, and changing things. It's a busy place, hidden from our everyday sight. For thousands of years, humans had no idea this world existed. Imagine that. People got sick, food spoiled, and no one knew why. It was a mystery. Then, about 350 years ago, a man named Antoni van Leeuwenhoek started looking at things through his homemade microscopes. He was just curious. He looked at pond water, his own teeth, scrapings, even blood, and what he saw amazed him. He saw animalcules, tiny dancing creatures swimming around. He was the first human to truly see bacteria and other microbes. This discovery didn't just change science, it changed how we understood life itself. It made us realize that our normal way of seeing the world was incomplete. What if the most important things were always too small to notice? It makes you wonder what else we might be missing, even now. Think about your own body. You are not just you. You are also a walking, talking ecosystem for trillions of these tiny microbes. In your gut, for example, there are billions of bacteria working hard to help you digest your food, make vitamins, and even help your immune system. They are silent partners in your health. Or think about bread. What makes dough rise? Tiny yeast, which are a type of fungus, eating sugar and making gas. What makes yogurt tangy? Bacteria transforming milk. These tiny living things, unseen by us, shape so much of our daily lives. From what we eat to how healthy we are. They break down dead plants in the forest, returning nutrients to the soil. They clean up oil spills. They are the silent workers of the planet. This unseen world shows us something deep about reality. It reminds us that our human senses, as amazing as they are, only show us a small part of the picture. There are layers upon layers of existence, some too small to see, others too big, others too fast, or too slow. It's a humbling thought. It means there's always more to discover, more to understand, right in front of us, or perhaps hidden within us. It invites us to be curious, to always look closer, to wonder about the things we cannot directly sense. The world is far richer, far more complex, and far more alive than we can ever fully grasp with just our eyes. And that's why it matters. It teaches us that true understanding often comes from beyond what we immediately perceive, asking us to trust that there is always more to wonder about, always more life happening, even in the smallest of spaces. The power of our wild imagination. Have you ever had a dream so real, so vivid, that when you woke up, it took a moment to remember it wasn't true? Or maybe you've been staring at the clouds, and suddenly, you see a dragon, a spaceship, or a giant floating dog. That, right there, is the beginning of what we're talking about. It's a quiet, powerful part of who you are, something deep inside every human being. Here's the thing, it's your imagination, and it's not just for making up fun stories. It's a tool for trying to understand things that might be beyond our grasp. So, what exactly is this wild imagination? It's not just pretending. It's the mind's ability to form new images, ideas, and concepts that aren't actually in front of us, or that might not even exist in the real world yet. Think of it like a personal movie projector inside your head, always ready to play whatever you can dream up. You can picture places you've never been, or feel emotions for people you only know from a book. This isn't magic. It's a fundamental part of how our brains work. For a very long time, people have wondered about this power. Ancient thinkers, way back in history, would talk about how humans could imagine perfect ideas, like a perfect circle or true justice, even though they never saw them perfectly in the real world. It was like our minds had a special way of reaching beyond what our eyes could see or our hands could touch. They thought this ability was a hint at something bigger, something we could only get close to by using our inner thoughts and pictures. It suggests that even the things we can't fully understand might first appear as a whisper, a faint image, in our own minds. Here's a way to think about it that might hit closer to home. Imagine you're building with Legos. You don't have instructions. Instead, you just start putting pieces together, making up a fantastical castle or a strange creature that no one has ever built before. You're seeing it in your head before your fingers even touch the bricks. Or maybe you're writing a story, and the characters just start talking in your mind, doing things you didn't plan. That's your imagination at work. It takes bits and pieces of what you know and mixes them into something entirely new. In science, this is how many big discoveries start. Someone imagines a new way something could work, a new theory, before they can prove it with experiments. They picture it first. And this leads us to a fascinating thought. If our imagination can help us build new things, write new stories, or even picture scientific breakthroughs, then maybe it also helps us try to touch the edges of things we truly can't understand. The biggest mysteries, like the universe's endlessness, or why we feel certain emotions, or even what happens after life. These are things we can't measure or explain simply, but we can imagine them. We can form ideas about them, even if those ideas are incomplete or always changing. Our imagination gives us a kind of courage to even approach these huge, unknown questions. It lets us explore the what-ifs and the how-could-be of everything that remains a mystery. It's a quiet strength, a gentle way of knowing that even when we don't have answers, we always have the power to wonder, to dream, and to picture what might be. What it really means to be human. Have you ever looked at a pet or seen a complex robot at work and wondered what makes us different? What truly sets human beings apart from everything else on Earth? It's a question people have asked for thousands of years, and it's not as simple as just having big brains or walking on two legs. Being human goes deeper than our bodies or even our incredible minds. It's about something we feel inside. We don't just react to the world, we experience it in a unique way. Think about emotions. We feel joy, deep sorrow, hope, and fear. But it's more than just a quick feeling. We can feel empathy, that incredible ability to understand and even share the feelings of another person. When you see someone sad, you might feel a pang in your own chest, even if you don't know exactly why they're sad. That connection, that shared feeling, is a big part of what it means to be human. We also have this amazing power to imagine. We can dream up things that don't exist yet. A new invention, a fantastic story, or even a different future for ourselves. We can think about things that aren't right in front of us. We can remember the past in detail and plan for the future. No other creature on Earth seems to do this in the same complex way. This ability to create, to invent, to build worlds in our minds, it's profoundly human. For a very long time, thinkers from ancient Greece to modern scientists have tried to answer this question. Some talked about a soul or a spirit. Others focused on our ability to reason, to think logically, and to solve problems. And some focused on our ability to make choices, to have free will. Think about it. We aren't just following instincts like many animals. We can choose to be kind, even when it's hard. We can choose to learn something new, even if it takes effort. These choices, big and small, shape who we are and what we become. Consider a simple example from your daily life. Imagine listening to your favorite song. A dog might react to the sound, maybe wag its tail or bark. But do they feel the sadness in a slow melody? Do they get goosebumps from a powerful beat? We can connect with music on a deep emotional level. It can remind us of memories, make us feel inspired, or even help us process complicated feelings. We don't just hear the notes, we feel their meaning. That's a distinctly human experience. Another example, when someone tells you a story, you don't just hear words. You imagine the characters, the places, the events. You might even feel what the characters are feeling. You can get lost in a book or a movie because your mind creates a whole world based on what you're told. This ability to create and enter imaginary worlds and to learn from them is powerful. It allows us to explore ideas, understand different perspectives, and even practice empathy without actually being in those situations. So, what does it really mean to be human? It's not about finding one single, simple answer. It's about being able to feel deeply, to think abstractly, to connect with others, and to seek meaning in our lives. It's about the joy of discovery, the comfort of belonging, and the quiet strength of knowing we can choose who we want to be. It's about the unique blend of our minds, our hearts, and our spirits. We are all on this amazing journey of discovery, not just about the world around us, but about ourselves and each other. And even though we might never fully understand everything about what it means to be human, just living it and thinking about it is part of what makes it so profoundly special. It's a mystery we share, a story we're all still writing. And that in itself is a beautiful thing.